Fire may be one of the greatest threats to humans living on the moon, and NASA is worried enough to start setting things on fire there on purpose. That sounds absurd at first. The moon has no forests, no oxygen-filled atmosphere, and no campfires crackling under the stars. But future lunar bases will be different. Astronaut habitats will be packed with electronics, fabrics, plastics, oxygen systems, batteries, and wiring. Inside those enclosed structures, a single spark could become a disaster. The problem is that scientists still do not fully understand how fire behaves in lunar gravity. On Earth, flames work in a familiar way because gravity constantly pulls cooler air downward while hot gases rise upward. That movement creates convection currents, the invisible flow that shapes a flame and sometimes even helps extinguish it. In some situations, flames lose access to enough fresh fuel and simply blow themselves out. But the moon changes the rules. Lunar gravity is about 6 times weaker than Earth's. That weaker pull means hot gases move much more slowly. Instead of rapidly lifting heat away from a fire, the lunar environment may allow oxygen to keep feeding the flame continuously without creating the airflow needed to extinguish it. In simple terms, materials that seem relatively safe on Earth could burn longer and more dangerously on the moon. That possibility alarms NASA engineers. A fire inside a lunar habitat would not just threaten equipment. In the worst case, it could destroy the entire station and everyone inside it. For decades, NASA has relied on a flammability test developed on Earth. Materials are exposed to a flame, and scientists observe whether the fire spreads. If it burns too far or produces flaming debris, the material fails. But there is a major flaw. Earth is not the moon. Space has already shown scientists that fire behaves in bizarre ways outside normal gravity. On the International Space Station, flames do not stretch upward like candles. Instead, they form slow-moving glowing spheres that drift through the air. Ventilation systems become the main force controlling how they spread. NASA has even conducted experiments in orbit, intentionally igniting more than 1,500 small flames to study combustion in microgravity. Later experiments aboard uncrewed cargo spacecraft revealed even stranger behavior. Some fires spread against airflow instead of with it. Thin materials sometimes burned hotter than expected. Still, none of those tests fully recreated lunar conditions. That is why NASA is preparing a new mission, called FM2, short for Flammability of Materials on the Moon. The experiment will send a sealed chamber with 4 solid fuel samples to the lunar surface. Once there, the system will deliberately ignite them while cameras and sensors record how the flames grow, spread, and consume oxygen in real lunar gravity. Scientists expect the results to begin to answer a critical question. Can humans safely build permanent homes on the moon without fire becoming an uncontrollable threat? Because right now, the honest answer is that nobody truly knows.
In February 2025, scientists detected an asteroid heading our way. If it hit, it would create a crater the size of Manhattan and unleash a shockwave strong enough to flatten everything within 30 miles. Uh-oh, I'm out of here. Well, luckily for now, we're in the clear. But the threat is coming back in 2028, and this time, everything might change. You see, in 2025, NASA announced that an asteroid called 2024 YR4 had a 3.1% chance of hitting Earth in 2032. Now, in asteroid terms, that's high enough to sound the alarm. The asteroid itself is not the end of the dinosaurs level, but it's big enough to level a city. The rock is about 130 to 300 feet wide. That's roughly the size of a large jet. Now, if something that size slammed into a populated area, it wouldn't end the world, but it would result in a very, very bad day. And still, no one panicked, and scientists weren't scrambling for bunkers. Because when we first spot an asteroid, we have to work with limited information. It's like seeing a plane high up in the sky and trying to guess exactly which gate it'll park at. That's why astronomers rush to gather more data. The asteroid itself seemed pretty ordinary. It was rocky, not some rare metal thing. It was first spotted in late 2024 by an observatory in Chile during a regular skyscan routine. There's this group called the International Asteroid Warning Network. Their job is to keep an eye on space rocks that might try to ruin your day. And back on January 29, 2025, they announced that the chances of that particular asteroid hitting Earth had gone over 1%. Now, 1% might not sound like much, but that's enough to make scientists start worrying. The impact risk for 2024 YR4 reached its highest point on February 18, 2025. That's when scientists calculated a 3.1% chance it could hit Earth. But by February 23, after more observations came in, that possibility was essentially ruled out completely. The asteroid's Torino scale rating, which is used to categorize the impact risk of near-Earth objects like asteroids and comets within the next 100 years, was lowered to 0. It means it's no longer considered a threat to Earth. Well, for now. But scientists still keep tracking it, and based on additional data, there is now a 4% chance it could hit the Moon instead. If that were to happen, it would be on December 22, 2032. Right now, the asteroid is expected to pass about 5,600 miles from the Moon's surface. However, there's a very large uncertainty range, about plus or minus 46,000 miles. So it could easily miss the Moon by a very large distance. The last time we had something this dangerous was back in 2004, with an asteroid called 99942 Apophis. Back then, it had a 2.7 chance of hitting Earth in 2029. People were sweating. But after better observations, scientists ruled out the impact. This time we actually passed that old record. 2024 YR4 is currently heading out toward Jupiter's neighborhood and won't swing back close to us until 2028. And that's when everything might change. If the risk jumps above 10%, the IAWN will send out a formal warning to the United Nations. They'll tell countries in possible impact zones to maybe start preparing, because if we talk about the damage… Admittedly, this asteroid is not the 6-mile-wide monster that wiped out the dinosaurs 66 million years ago after hitting Earth. This here asteroid is in the city killer category. It sounds dramatic because it is, but it's not some global extinction stuff. The real problem isn't just its size, it's its speed. If the asteroid hits, it could be moving nearly 40,000 miles per hour. That's like flying from New York to LA in under 5 minutes. But still, the most likely scenario would be the asteroid exploding in the air before even hitting the ground. That's called an airburst. But if the asteroid is on the bigger end of the size estimates, it could actually reach the surface of our planet, slam into the ground, and make a crater. So that possibility's still on the table. As for where it could hit, the possible impact zone covers a huge area: Eastern Pacific, Northern South America, the Atlantic, Africa, the Arabian Peninsula, and South Asia. Raise your hand if we left you out. Keep in mind, though, that it's way too early to make life decisions based on that. So, no packing up and moving yet. Besides, we're not sitting here helpless. In 2022, NASA pulled off the DART mission, where they literally smashed a spacecraft into an asteroid to nudge it off course. And it worked. DART stands for Double Asteroid Redirection Test. It was built for NASA's Planetary Defense Office. They wanted to know if we could push an asteroid just enough for it to miss our planet. So they launched a spacecraft in November 2022, and it traveled through space for about 10 months. The plan from day one was to crash it. The target was a small asteroid moon called Dimorphos, which is about 530 feet across, the size of a large stadium. Dimorphos orbits a bigger asteroid called Didymos. The two of them just circle each other out there in space. What's important is that neither of them was threatening Earth, So this was a safe test. Now DART was basically a heavy spacecraft with a camera and a smart guidance system. The strategy was to hit Dimorphos at about 14,000 miles per hour and let the force of that impact slightly change its orbit. In the final stretch, the spacecraft guided itself. It had to figure out which rock was which, lock onto the smaller one, and adjust its path without anyone steering it in real time. When it hit, the onboard camera sent back close-up images right up until the moment of impact. Then the signal stopped because the spacecraft had done its job and smashed into the asteroid. There was also a small Italian CubeSat that separated earlier and stayed back to photograph the collision and the resulting debris cloud. Those images showed a huge plume of rock and dust blasting out into space. Well, after that, astronomers around the world started measuring the orbit of Dimorphos very carefully. Before the collision, it took 11 hours and 55 minutes to circle Didymos. After the impact, it took 11 hours and 23 minutes. That's an impressive 32-minute difference. The interesting part was that the spacecraft alone wasn't responsible for all of that shift. When DART struck the surface, it threw tons of rocky material outward. All that rock and dust blasting off gave the asteroid an extra push, stronger than the spacecraft alone could have done. Scientists later realized that Dimorphos wasn't a solid chunk of rock. It was more like a loose pile of rubble held together by gravity. That probably helped produce more debris and a bigger push. So if we ever face a denser, more solid asteroid, the same technique might not have the same exact effect. That's why scientists are also looking at other ideas, like using lasers to heat up part of the asteroid so bits of rock fly off and slowly push it in the opposite direction, like giving it a tiny built-in rocket. Or they could place a spacecraft close to the asteroid and use its gravity to slowly pull it off course, like a small tugboat guiding a huge ship. Or if things got really serious, use a nuclear blast as a last resort shove. Despite the success of the DART mission, NASA says we do not have a ready, reliable system that could stop a city-killing asteroid if one suddenly shows up on a collision course with Earth. The danger isn't the giant dinosaur-level asteroids. Those are huge and easy to track. Neither is it tiny rocks that burn up in the atmosphere all the time. It's the middle-sized ones, around 500 feet wide. Scientists estimate there are about 25,000 near-Earth objects in that size range moving near Earth's orbit. So far, we've only found about 40% of them. That means most of them are still out there, and we don't know exactly where they are. The problem is they're dark. Most don't reflect much sunlight, so even powerful telescopes can miss them. To help fix that, NASA plans to launch a new space telescope called the Near-Earth Object Surveyor. Instead of looking for sunlight bouncing off asteroids, it'll look for heat. Even a dark asteroid absorbs sunlight and gives off heat, and that's easier to see in infrared. So check this out. The most powerful telescope we could ever use already exists. It doesn't need a lens or a giant glass mirror. This telescope is 4.5 billion years old, 109 times wider than Earth, and has a diameter of 864,000 miles. Yep, the Sun itself might become our telescope, and it's totally doable. Now, the Sun isn't a lens or a mirror like in a regular telescope, but it's supermassive, and according to Einstein, heavy stuff like that can bend space and time around it. When light passes close to the Sun, our star's gravity bends it, and instead of traveling in a straight line, the light curves slightly as it goes by. Imagine a heavy bowling ball sitting on a stretched sheet. The sheet dips around it. If you roll a marble nearby, it won't go straight. It will curve toward the dip. The Sun does the same thing to light. Its huge gravity slightly bends passing light inward. And that bent light ends up gathering at a distant point, which is called a focal point. Astronomers already use this trick, called gravitational lensing, to watch the farthest galaxies in the universe. When light from a very distant galaxy passes near a huge cluster of galaxies, the cluster's gravity bends and kind of boosts that light. It works like a natural cosmic magnifying glass. and makes the faraway galaxy look brighter and larger. This way, we can see much farther than we normally could. Now picture this. Light is coming from a planet or star billions of miles away and grazes the sun as it passes by. Thanks to gravity, the sun bends it. Now all we have to do is put a sensor at that focal point and catch the light. It sounds simple, but there's a problem, like always. That focal point is about 542 astronomical units from the sun. To put that in human terms, that's 542 times the distance from Earth to the Sun, 13 times farther than Pluto, and more than 3 times farther than Voyager 1, the farthest human-made object has been traveling through space since 1977. In other words, sending a spacecraft that far, keeping it alive, and getting it to do its job isn't a weekend road trip. Plus, the focal point isn't a tiny dot. It's more like a huge lighted patch tens of miles across. If you park your spacecraft in one spot, you'll only see a tiny slice. And if you want the whole picture, you'll have to move it across all that gigantic focal area, scanning bit by bit. But it's even more difficult than that. The target you're trying to image, another planet or a distant star, isn't standing still. By the time your spacecraft reaches the focal area, it can't just aim anywhere and hope for the best. You have to predict exactly where the target will be, or your telescope will be staring at empty space. It means that even though the sun's gravity provides us with a cool natural lens, using it is super complicated. You'll have to deal with huge distances, moving targets, and a focal area bigger than the largest cities on Earth. But what if we managed to pull it off? Then we'd be able to see things in the universe with a clarity no other telescope has ever matched. Now, the crazy part here is that this plan isn't some sci-fi nonsense. We'd have to send a spacecraft, or maybe a whole swarm of them, 3 times farther than Voyager. But after all, that's not hopping to another star system. This is still inside our solar system. It's just really far. One idea experts have entertained for decades is the Super Voyager approach. It goes like this. You just fling a probe out there, let it zoom through the sun's focal point, collect whatever light it can, and beam it back. Great! But you only get a tiny snapshot of a minuscule patch of your target. It's not even a full-blown image. It's like looking at a single pixel of the Mona Lisa and claiming you've seen the entire masterpiece. What we really need is a spacecraft that can hang out there, move around, and scan the whole focal area, slowly mapping a target in precise detail. The latest proposals don't even involve one big spacecraft. They suggest a swarm of tiny spacecraft, all working together to create a full picture. They could be like a team of painters working on a huge wall. But that's not easy. Tiny spacecraft still need instruments, power, and fuel. This will make them bigger and heavier. It kind of defeats the whole point of having tiny ships. Then, how about solar sails? The idea is really cool. We could launch the swarm from Earth, let them travel toward the sun, unfurl their sails, and let solar radiation pressure, which is basically sunlight, push them like cosmic sailboats. They would accelerate insanely fast and reach 542 AU in a few decades, which is pretty long, but not impossible. After arriving at their destination, they carefully move in formation across the huge focal plane, each one collecting its own slice of light. Then, they'd beam all that data back to Earth, helping us build the whole picture using the sun as the most epic telescope ever. What could we get with this crazy setup? Well, point it at Proxima b, the nearest exoplanet, and you could see an almost 1-mile resolution. Compare that to the next-gen space telescopes, where the whole planet is just a few blurry pixels. You could see mountains, oceans, maybe even continents of any planet within 100 light-years. Imagine everything else we could observe. No wonder that a lot of research has gone into this, but there's still a huge gap in our capabilities. Right now, we don't have solar sails that are powerful and efficient enough, and we certainly don't have swarms of spacecraft that can coordinate and operate together at that distance. all the current proposals are impossible at this moment. They're just beyond today's technology. But with the right breakthroughs, though, it's entirely feasible. After all, we already have some incredibly powerful telescopes that provide us with breathtaking views of the universe. Like the James Webb Space Telescope. Such machines are true engineering monsters, billions of dollars, decades of work, and giant mirrors. For example, James Webb's mirror is 21 feet across and can resolve details about 600 times sharper than the human eye. At that resolution, it could read the pattern on a coin from 25 miles away, or see the design on a soccer ball sitting over 340 miles away. Or take the Hubble Space Telescope. It detected elements from the early universe, proved that supermassive black holes existed, and showed black holes at the heart of galaxies. It captured the first collision between astronomical objects, spotted oxygen in a moon's atmosphere, and even took the first image of a star's surface other than the Sun. It gave us the first visual evidence of planetary building blocks, first exoplanet atmospheres, and even found organic molecules in other worlds. It photographed asteroids with tails, captured asteroids breaking apart, and detected water vapor plumes on Europa, one of Jupiter's largest moons. Hubble saw the first predicted supernova, the farthest galaxy and star ever imaged at the time, and water vapor on an exoplanet in the habitable zone. It even snapped the first ultraviolet image of a forming exoplanet and spotted a possible moon orbiting an exoplanet. Then there's the Event Horizon Telescope, which isn't just one telescope, it's a global network. By syncing instruments around the world, it gave us mind-blowing images of gas swirling around black holes. Its resolution is 20 microarcseconds, which means it could spot an orange on the moon. And still, if we wanted to go even bigger, we'd need massive dishes or swarms of telescopes flying through space, which would be like building a telescope the size of a small country. That's why the Sun as a telescope is such a great idea. It already has the mass, the bending power, and it's sitting there for free. We just need a camera in the right place to catch all that light. Behold a city-sized power plant built by robotic spiders floating in orbit, transporting energy down to Earth as a beam. To us, it sounds like a crazy sci-fi idea, but for engineers, it's a very real project. The pieces are being tested, and space agencies want to have the whole system online in less than 30 years. Now, it wasn't that long ago that large-scale solar power felt unrealistic. Today, it's widespread and the most affordable form of energy. The biggest solar power plant on the planet, the Golmud Solar Park, has almost 7 million solar panels, and it could produce an unbelievable 2.8 gigawatts of electricity. That's enough to power more than 2 million homes and about twice the energy needed to power the DeLorean time machine from Back to the Future, if you're keeping track. Now, all this sounds great on paper, but in reality, it's a major headache. Large-scale solar power takes up massive amounts of land and needs constant upkeep. More importantly, solar panels on Earth never hit 100% efficiency. Our atmosphere acts like a pair of dirty sunglasses and scatters roughly 30% of the sun's energy before it even reaches the glass. Also, sunlight is unreliable. Remember those puffy things called clouds? Solar panels are like employees who take sick days when it's cloudy, barely work during winter, and sleep every single night. Hey, I had a job like that once. To keep the lights on at night, we have to rely on massive battery systems to cover that gap. Well, that's why engineers started looking for a loophole, or better said, a better location. If you travel about 22,000 miles straight up, you reach a geostationary orbit. This is the cosmic sweet spot. Up there, a satellite stays fixed over the same point on Earth. You get unfiltered sunlight non-stop every single day for a year. Well, almost. Twice a year, around the equinoxes, Earth slips in front of the Sun and throws a shadow across that orbit, creating a short blackout that can last up to 72 minutes. And then the sunshine is back on as if nothing happened. Well, finding a reserved parking spot in a 22,000-mile orbit isn't the hardest part. It's building the thing to do the work there. Depending on the design, NASA wants the structures to be anywhere from a couple of miles to nearly 6 miles across. We can't fit something like that on a rocket. The ISS is about the size of a soccer field and took more than a decade and over 40 launches to assemble. So, engineers are flat-packing it like IKEA furniture. The plan is to launch thousands of identical ultra-thin squares of mirrors and electronics, stacked like dinner plates inside a heavy-lift rocket. Something like this would be impossible for humans to assemble. It would take centuries of going up and down. That's why it's a job for little robots that might look like spiders, crawling over a giant metal web, snapping modules into place until the structure grows into a floating power city. But once the station is assembled, the coolest part is the delivery. You can have a massive amount of electricity stuck in orbit, and they don't really make extension cords and cables that reach up that far. So, engineers would have to turn that electricity into a beam. The station would convert the raw power into microwaves, or in some designs, low-intensity lasers. These are basically the same waves that heat your leftover lasagna. That beam is then aimed at a specific target on the ground. Wait, a beam from space? What if some bird gets in the way? That sounds like something from movies where a giant laser fries a city. Well, actually, making and using that kind of weapon isn't unrealistic at all. It's just impractical, and the world lacks a proper villain. But this isn't a tight laser pointer. Over the distance that long, the beam naturally spreads and is designed to arrive wide for safety and control. So, by the time it reaches the ground, it's almost 4 times weaker than standing outside on a sunny day. And if a bird flew through the beam, it wouldn't go poof into feathers and smoke like in a cartoon. The whole energy beam from out of space isn't just a theory, and it's been tested. In 2023, Caltech's MAPLE experiment successfully beamed power wirelessly in orbit for the first time. They proved you can actually send energy through the void and catch it on the other side. On Earth, we catch it with a rectenna. That sounds high-tech, but visually, it looks like a giant fishing net made of wire mesh stretching for miles. It's not a slab of concrete and is, in fact, almost transparent, so much so that rain falls straight through it. That's because it doesn't need to reflect or block light. It's built to intercept specific microwave lengths. In theory, you could build multiple rectennas and switch targets as the station and Earth line up, like routing a call to a different tower. Right now, the Space Solar Project isn't waiting on some technological breakthrough. It depends more on a bunch of boring things getting cheaper at the same time. The biggest one is launches. A few decades ago, putting 2 pounds into orbit cost tens of thousands of dollars. Today, reusable rockets have cut that price by a lot. The more rockets fly, the cheaper each flight gets. Space Solar only starts to make sense when sending cargo to orbit feels less like a scary moon mission and more like basic freight shipping. The second piece is mass production. These stations aren't crafted like you need spacecraft. Instead, they're more like factories. They're made up of thousands of identical ultra-thin panels, all the same shape and size, with the same connections. It's the kind of stuff you mass-produce in millions, not something workers could assemble by hand. In the meantime, engineers also have to prove that everything can function on a small scale. The tests are already happening in bits and pieces. We're seeing small satellites, short power beams, and demos of autonomous assembly. NASA's own 2024 study models a path where the tech matures in the 2030s. The giant station gets assembled in the 2040s, and power delivery could start around 2050, which is not really that far. Also, breakthroughs can happen and push the project forward in an unexpected way. Now, building a project like this sounds wildly ambitious, but it's actually the first realistic step, just one of many bigger ideas that are still waiting in the far future. For example, what if you don't put the panels in Earth orbit at all? What if you put them closer in instead, where sunlight hits harder and every panel pulls in more energy per square foot? You build a station that lives in permanent daylight, then beams power outward like a lighthouse. One other idea keeps the same beam-it-down concept, but changes the build strategy. Instead of one giant city station, you split it into a whole constellation of smaller power satellites, like cell towers but in orbit. One satellite lines up over a rectenna, beams power down for a while, and then hands off to the next one, sliding into position. From the ground, it looks like a relay race in the sky. A chain of satellites marching around the planet, passing the beam from one to the next. And if one unit fails, the whole system doesn't go dark. The rest keep working, while robots swap in a replacement like a flat battery. And then we have the coolest and most famous one, a Dyson swarm. Not a solid shell, but a cloud of millions of collectors orbiting a star, grabbing a huge chunk of its output. If a civilization built that, the star itself could look wrong from far away, like somebody dimmed it on purpose. Any of these ideas belongs to a different era, when building in space is cheaper, easier, and maybe powered by technology we don't even have yet. But one thing is already obvious. From the moment we wake up, we're surrounded by devices that guzzle electricity, and we keep demanding more. So it's not surprising that, slowly but surely, people are starting to look up at space as the next place to scale energy. For now, all we can do is wait for the next big upgrade. And maybe remember to turn off your devices when not using them. Just saying. Wow, nobody could have predicted this. Thousands of Airbus planes had to be grounded at once. Was it a technical glitch, a construction mistake, a human error? Not at all. It happened because the plane's computers might get messed up by something coming straight from space, something that could cause a terrible disaster and claim hundreds of lives. Now the thing is, our sun is always shooting out charged particles, like a powerful invisible wind. And on top of that, we're constantly getting hit by even stronger particles from outside our solar system. Those are called cosmic rays. We never feel them, but they're always there. Most days they're harmless. But sometimes the sun fires off a massive burst, a solar storm. And that stuff can seriously mess with electronics. It's also what triggers those insanely bright auroras. Now, because of this risk, Airbus checked around 6,000 planes. About 5,000 of them needed a simple software update. But around 900 older planes needed a whole new computer. According to Airbus, radiation from the sun might have corrupted data that's essential for flight control. And this issue could have affected many A320 aircraft already in service. The main problem is a piece of software that calculates the plane's elevation. If high-energy particles hit the computer at the wrong moment, the hardware can glitch, and that glitch becomes a software error. You see, when planes fly high, the air is thinner, so more space particles get through. If one of those particles hits a microchip, it can flip a tiny bit. A 0 becomes a 1, or a 1 becomes a 0. That tiny flip is called a single-event upset, and it can make electronics act weird. You can probably imagine the catastrophic outcome an altitude-related mistake can lead to. Airbus planes are finally getting back to normal after the company rushed out a software fix, which was way faster than anyone expected. By the way, the warning itself came after a JetBlue flight ran into trouble mid-air when a solar flare may have messed with its flight controls. That JetBlue plane was flying from Cancun to New Jersey when something suddenly went wrong. The jet dropped sharply. It was fast enough that people were thrown around the cabin. Some passengers hit the ceiling. Around 15 to 20 people ended up in hospitals. At 2:19 p.m., the pilots made an emergency landing in Tampa. Medical teams immediately rushed on board. JetBlue pulled the plane from service immediately, and the FAA is now digging into what exactly happened. In any case, these days we rely a lot on watching the sun. There are satellites in space right now whose only job is to track solar tantrums and warn us before they cause trouble. Luckily, we're finally heading toward a calmer period of the sun's cycle, but it never truly quiets down. Even when our star seems calm, it's still firing particles at us non-stop. And recently, scientists from several countries found something hidden in ancient tree rings, a huge jump in radiocarbon dating from about 12,350 BCE, right near the end of the last ice age. For years, no one could tell how strong this spike really was because there was no good way to model it. Now, with a new climate chemistry model, researchers have finally figured out that this thing was the most powerful solar particle storm ever found. Nothing else in the record even comes close. The team built a special model. It's designed to recreate how the atmosphere behaved during glacial times, letting them study ancient solar storms. And when they tested the model on the newly discovered event, they found it was even stronger than the famous AD 775 storm, which used to be considered the biggest one on record. Compared to a strong solar storm from 2005, the Ice Age event was hundreds of times more intense. Other big historical storms did happen long ago, around 994 CE, 663 BCE, 5259 BCE, and 7176 BCE. Hey, I wasn't around then. But none of them reached this level. The researchers also checked the model using wood found in the French Alps that dates back around 14,300 years, so the timeline lines up. Solar particle storms don't happen often, but when they do, they blast Earth with high-energy particles that can change the atmosphere and leave clear marks in tree rings. Even the famous Carrington event of 1859, which knocked out telegraph lines around the world, was actually a different kind of solar outburst. What makes this new discovery stand out is that it's the only known extreme solar particle event from before the last 12,000 years of warm climate. Until now, scientists could only look for such storms inside that window. But with this new model, the scientists were finally able to figure out how strong this ancient solar outburst really was, when it hit, and what it might have done to Earth. The model now works for both warm periods and for the cold, icy world that existed before it. That's a big step forward for studying old radiocarbon spikes. The team focused on how solar particle storms can pump huge amounts of extra radiocarbon into the atmosphere. Normally, this type of carbon forms when cosmic rays hit our air. But during one of these extreme storms, the amount shoots up fast, and trees trap that sudden jump inside their rings, which basically creates a time stamp that survives for thousands of years. These sharp spikes, known as Miyake events, have already helped scientists date things like Viking settlements in North America and early farming communities in Greece. This ancient blast sets a new upper limit for what our star can do, and it's alarming. Knowing the size of the event is crucial. A storm of that scale today could threaten satellites, mess with communication systems, and overload power grids. It gives researchers a clearer picture of the most extreme kind of space weather our planet might ever face, and what it could mean for modern life. Now luckily, Earth is wrapped in a kind of invisible shield that blocks most of the dangerous particles the Sun throws at us. For almost 10 years, 4 small NASA spacecraft, called the MMS mission, have been flying right along the edge of that shield, watching how it bends, snaps, and reacts to the Sun's magnetic forces. Now during one of those passes, the probes caught something nobody expected: a sharp twisting bend in Earth's magnetic field. Scientists call this kind of shape a switchback. They've seen them near the Sun before, but never this close to Earth. Finding one in our space neighborhood is kind of like spotting a wave curling backwards in the middle of a calm lake. This switchback showed up in the magnetosheath, the turbulent zone where the solar wind slams into Earth's shield and gets pushed aside. Inside the twist, the probes picked up fast, energetic electrons that came from Earth's own magnetic field. They were mixed with particles from the Sun, and everything was spinning together inside this strange structure. The spacecraft recorded how the magnetic field flipped, how fast the particles were moving, and how the whole thing behaved. The twist seemed to come from a process called magnetic reconnection, where magnetic fields from the Sun and Earth snap together and release a burst of energy. These bursts can set off bright auroras. But the big ones can also knock out satellites or mess with power grids. The MMS probes will keep flying through the area, hunting for more twists and bursts. trying to pin down what causes them and which ones are strong enough to mess with our technology on the ground. The problem is that tiny magnetic snap might let radiation push far deeper into our atmosphere. And now, scientists are starting to connect the dots. Strange aviation glitches, signs of ancient megastorms buried in old trees, and now a fresh crack in our magnetosphere. Together, they paint a worrying picture. We depend on calm space weather for everything – planes in the sky, GPS, satellites, even the power running through our homes. The Airbus grounding might end up looking like a gentle warning, the first hint that something much bigger could be building out in space. A recent shocking discovery, shocking I tell you, shows that one galaxy can devour another smaller one, leaving behind just faint remains. Can anything like this happen to our home Milky Way galaxy? And if it does, what will happen to the inhabitants of the planet Earth? You know, us. Well, let's figure it out. This whole discovery is actually a curious story. Even before the Rubin Observatory, an astronomical observatory in Chile, even started its full science work, it accidentally helped astronomers spot something totally unexpected. In June, the team released its very first test images, and one of them showed a deep look at the Virgo cluster. That's a huge group of nearby galaxies scientists have been studying for years. But in the bottom right corner of that image, there was something thin and strange, and it wasn't me. It was a tiny razor-sharp streak of stars stretching away from a well-known galaxy called M61. No one had ever seen it before. Now, M61 looks a lot like our own Milky Way galaxy. It's a barred spiral galaxy with long, sweeping arms. But despite the similar shape, the center of M61 is far more dramatic. While Milky Way's supermassive black hole sits quietly, almost as if it's asleep, M61's black hole is wide awake and hungry. It feeds on surrounding matter and blasts out powerful flows of energy, which creates a kind of galactic storm that spreads through the galaxy. M61 has been studied for decades, but Rubin's camera is built to pick up things that are extremely faint. That's why this new star system suddenly appeared. It was as if someone turned on a flashlight in a dark room. Now, the stream is enormous. It's about 50 kiloparsecs long, which is roughly 163,000 light-years. That's more than the size of the entire Milky Way. Most stellar streams around our own galaxy are only a few tens of thousands of light-years long, so this one is huge by comparison. Scientists think that the long trail is made of a dwarf galaxy that got too close to M61. Once it crossed into the larger galaxy's territory, the dwarf galaxy became trapped in its gravitational grip. Little by little, powerful tidal forces began pulling it apart, stretching it into a long, faint trail of stars. Eventually, it was completely ripped apart by M61's gravity. When that happened, the larger galaxy seemed to have responded with a burst of new star-making about 10 million years ago. It almost felt like the collision kicked it awake. This process, large galaxies tearing smaller ones apart, is thought to be one of the main ways galaxies, like the Milky Way and M61, grow over billions of years. Each smaller galaxy that falls in becomes fuel for the larger one, adding stars and gas, and sometimes this process can even stir up activity around the central black hole. Will our Milky Way become that smaller galaxy one day? Well, we do have a much bigger neighbor, the Andromeda Galaxy. But at the moment, we can't predict whether it'll get hungry enough to attack the Milky Way. Whew, what a relief. Anyway, it might seem weird that the M61 stream had gone unnoticed for so long. It wasn't exactly faint or subtle, you know, glowing with the light of about 100 million suns. Hard to miss. But it managed this trick by staying hidden behind a nearby galaxy. This makes it really difficult to detect even bright stellar streams. To find them, we need extremely sensitive instruments and careful techniques. At least now we know that giant galaxies may grow by eating smaller ones, leaving long trails of stars behind as evidence. The researchers admit that it's surprising that such a huge structure stayed hidden around a famous galaxy for so long. And it seems that the discovery of the M61 stream is just the beginning. The night sky might start filling with new, uncovered structures, ghostly trails, forgotten galaxies, and the remains of ancient cosmic encounters. The Rubin Observatory is a brand new astronomy center built on a mountain in Chile. Its full name is the Vera C. Rubin Observatory. It was named after the astronomer who first found strong evidence that dark matter is real. Now, what makes Rubin special is that it's the first telescope of its kind. Its giant mirrors, super-sensitive camera, fast movement, and powerful computers all use cutting-edge technology. The main telescope, called the Simonyi Survey Telescope, has a 27-foot mirror, and it uses the LSST camera, which is the biggest digital camera ever made. But we'll talk about it a bit later. For 10 years, this telescope will take extremely detailed pictures of the southern sky. It will scan the entire sky every few nights, creating a huge, high-quality time-lapse video, the largest movie of the universe ever recorded. This movie will help scientists spot things that change over time, like asteroids, comets, stars that get brighter or dimmer, and exploding stars called supernovae. To create this giant time-lapse, the Rubin Observatory will have to use a lot of new technology. Some of its parts were invented from scratch, and others were improved versions of older designs. It'll help scientists discover all kinds of things. Many we already expect, and many we can't even imagine yet. Even so, Rubin Observatory was built with 4 main science goals in mind: learning more about dark matter and dark energy, creating a complete list of objects in our solar system, mapping the structure of the Milky Way, and studying objects that move or change brightness over time. Everything about the telescope, its huge size, fast scanning speed, and ultra-sensitive camera, was designed to make discoveries in these 4 areas as complete as possible. Rubin's telescope isn't the first telescope with a mirror about 27 feet wide, but it is the first to combine its primary mirror and tertiary mirror into one single surface. Putting both mirrors together is a special innovation that makes the entire telescope more compact. Because of this, it can move faster and get ready for its next observation much more quickly. The telescope's LSST camera is the biggest digital camera ever created. It's about the size of an SUV and weighs around 6,000 pounds. It holds a giant 3,200 megapixel CCD array. Just one single picture from Rubin is so large that you'd need about 400 Ultra HD TV screens to display it. It's also the fastest-moving large telescope on Earth. Rubin's telescope can swing into a new position in only 5 seconds and immediately start taking its next image. This speed comes from the telescope's compact design, thanks to its 2-in-1 mirror and its powerful drive motors. They can quickly move and stop the 220-ton telescope mount without shaking it. Even small vibrations can ruin an image, so this stability is a huge achievement. By the way, if the telescope were spinning at full speed, you wouldn't be able to outrun it. Also, Rubin Observatory has a rare combination. It can collect a lot of light and capture a very large area of the sky in a single picture. This means it can spot faint objects spread out over a wide region without needing many separate images. When you add the telescope's incredible speed, you get the perfect setup for creating Rubin's ultra-high-definition 10-year time-lapse of the universe. A fun fact, each Rubin image covers about 10 square degrees of sky. That's the same area as 45 full moons, or about the size of a golf ball held at arm's length. Another cool thing is that Rubin data will be immediately available to scientists in the US and Chile, and to members of Rubin's International In-Kind program. They'll be able to access everything through an online portal, which means that no giant downloads are needed. After 2 years, the entire world will be able to view Rubin data. Rubin will also process new images every night in near real time. If something in the sky moves or changes, the system will send out a public alert within 60 seconds. This will allow scientists to respond quickly and point their telescopes at the event. Each night, Rubin Observatory will create 20 terabytes of data and send out up to 10 million alerts about changes in the sky. By the end of the 10-year survey, Rubin will have produced a whopping 60 petabytes of raw images. It'll be the first time so much astronomical information is shared with so many people.
In 2022, we deliberately destroyed a multi-million-dollar mansion by smashing a spaceship into an asteroid called Dimorphos, just to see if we could nudge it off course. And now, in late 2026, another spacecraft is arriving there to check out the huge crater we left behind, and the future of our planet kinda depends on this mission. How come? Let's figure it out. First things first, let's figure out what the DART mission was and how it did its magic. DART stands for Double Asteroid Redirection Test. It was a mission built for NASA's Planetary Defense Program. Sounds like something from Star Wars. The idea was simple but important. If an asteroid were ever heading toward Earth, could we nudge it just enough so it would miss our planet? It's like with a rolling ball. A small tap can change its path so it moves past you instead. Scientists wanted to see if the same idea could work with asteroids. So NASA launched the DART spacecraft in November 2021. It spent about 10 months traveling through space before it reached its target, which was a small asteroid called Dimorphos. It was about 530 feet across, roughly the size of a large sports stadium. It orbited a bigger asteroid named Didymos. Neither of those asteroids was dangerous to Earth. That's why scientists chose them. It meant they could run this one-of-a-kind experiment safely. No need to worry about accidentally sending a real threat our way. The DART spacecraft itself was pretty simple. It was something like a heavy box with solar panels, a camera, and a smart navigation system. The plan was to slam it into Dimorphos at an insane speed of 14,000 miles per hour. That's fast enough to travel from New York to Los Angeles in about 10 minutes. But hitting a small rock in space isn't easy, especially at such a high speed. In the final hours of the mission, the spacecraft had to guide itself because signals from Earth took too long to travel back and forth. The probe used its camera and software to figure out which asteroid was the big one and which one was small. Then it locked onto Dimorphos and adjusted its path automatically. As the spacecraft rushed closer and closer, the camera kept sending images back to Earth. Scientists watched the asteroid grow larger until suddenly the transmission stopped. That was when DART smashed into the surface. Luckily, there was also a small Italian mini-satellite traveling with DART. Earlier in the mission, it separated and stayed at a safer distance. When the impact happened, this little spacecraft photographed the immediate aftermath of the collision and the resulting debris cloud. A huge plume of dust and rock blasted into space, stretching thousands of miles away from the asteroid, like a cosmic smoke trail. After the crash, astronomers around the world started measuring Dimorphos. Before the impact, it took 11 hours and 55 minutes for the asteroid to circle Didymos once. After the collision, that time changed. Now, the orbit took 11 hours and 23 minutes. This difference of 32 minutes is actually a big shift for an asteroid orbit. It meant the experiment had worked. But there was one catch. The spacecraft wasn't the only thing that pushed the asteroid. When DART slammed into the surface, it blasted a huge amount of rock and dust into space. All that material flew away, acting like the exhaust from a rocket engine. It gave the asteroid an extra shove, and that shove was much stronger than the spacecraft alone could have caused. Besides, soon, scientists realized something else. Dimorphos probably wasn't one solid rock. It was more like a loose pile of rubble with lots of smaller rocks and dust clumped together by gravity. Imagine a floating gravel pile instead of a single giant boulder. Ah, now you get it. So, because the asteroid was kinda loose, the impact kicked up much more debris than the researchers expected, and it resulted in a stronger push. The problem is, that might mean that another asteroid will behave differently. And if we ever have to deal with a solid, dense asteroid, the same trick might not work again. That's why scientists want to find out what really happened to Dimorphos after the crash. We know the asteroid's orbit changed, but we don't understand yet how the impact changed its surface or what the inside of the asteroid looks like. That's why we had to send a follow-up mission. The European Space Agency launched the spacecraft Hera, named after the Greek deity of marriage, to take a closer look. Hera is supposed to fly to Dimorphos and study the asteroid in detail. The spacecraft will map the crater left by the collision, measure the asteroid's new orbit, and study how the surface changed when DART slammed into it. It will also try to learn what's beneath the surface of that space rock. It'll go like this. Once Hera arrives, it won't just fly past the asteroids. Instead, it will orbit the system for several months, studying it from up close. It'll measure the crater and map the surface in detail. This way, scientists will be able to figure out exactly how the impact changed the asteroid. Hera won't be working alone. About 6 weeks after arriving, the spacecraft will release 2 tiny helper satellites called Milani and Juventus. These small spacecraft are known as CubeSats, mini satellites about the size of a shoebox. One will study the chemical makeup of the asteroid's surface, helping scientists understand what the rock is made of. The other will look beneath the surface, using special instruments to learn what the inside of the asteroid is like. Hera is a part of our first mission to closely study a binary asteroid system. Such systems are still a bit of a mystery to scientists, even though they make up about 15% of near-Earth asteroids. While it's there, Hera will also help researchers test several new technologies. For example, it'll use autonomous navigation. That means it can guide itself around the asteroid without constant instructions from Earth. Kind of like how self-driving cars navigate roads here on Earth. Hera will give scientists a clearer picture of how asteroids behave in a crash. That way, next time we try to push one off course, we'll know exactly what to expect. By the way, DART and Hera were designed together from the beginning as part of an international project called the Asteroid Impact Deflection Assessment. Missions like DART and Hera are helping scientists learn how to protect Earth if a dangerous asteroid is ever discovered in the future. Because, according to NASA, we still don't have a fully ready and reliable system that could stop a city-killing asteroid. The thing is, the biggest asteroids, the kind that wiped out dinosaurs, actually aren't our main worry. They're enormous and, therefore, much easier to spot and track with telescopes. Scientists would almost certainly see them coming many years in advance. Tiny space rocks aren't a problem either. Small pieces of debris enter Earth's atmosphere all the time, and most of them simply burn up in the sky before they ever reach the ground. The real threat is medium-sized asteroids, about 500 feet wide. That's around the size of a large skyscraper, or several football fields laid end to end. An asteroid that size could destroy an entire city if it hit Earth. Scientists believe there may be about 25,000 near-Earth objects of this size moving around the Sun on paths that pass close to Earth's orbit. But so far, we've only discovered about 40% of them. That means most of them are still out there, and we don't know exactly where they are. Many of them are extremely dark and reflect little sunlight. That's why even powerful telescopes can sometimes miss them. No wonder experts are exploring different ideas for planetary defense. One option is using powerful lasers. The laser could heat part of the asteroid's surface until bits of rock start flying off into space. Those escaping particles would act like tiny rocket exhaust, slowly pushing the asteroid in the opposite direction. Another idea is something called a gravity tractor. A spacecraft would park near the asteroid and hover there for a long time. Its gravity would pull on the asteroid, slowly tugging it off course. It's like a small tugboat guiding a massive cargo ship. And if things ever get really serious, there's still a last resort option: using a nuclear blast near the asteroid to give it a powerful shove. Yes, we have maps, we have math, and we have the laws of physics. We also know how stars burn and how black holes eat light. Let's be honest, we like to think we understand the universe and feel pretty confident about it. And now imagine that all of that is correct and wrong at the same time. There are specific spots in deep space that shouldn't exist. We're talking about places that are too big, too empty, or too powerful for our science to handle. When astronomers look at them, the data doesn't just look weird, it looks broken, like a glitch in a video game. So, forget the standard textbook stuff. Today, we're looking at anomalies. The places where science hits a wall and the mystery begins. So, maybe in the end, we will find out that we do, in fact, live in a multiverse? First, let's talk about speed. We can assume that right now you are sitting still, but you aren't. Earth is moving, the sun is moving. Our entire galaxy, the Milky Way, is rushing through space at over 1.2 million miles per hour. To put that in perspective, at this speed, you could travel from Earth to the Moon in about 10 minutes. It is a velocity that the human brain can barely comprehend. And the scary part isn't the speed, but the destination. We are being dragged toward a specific point in the sky. Something massive is out there, acting like a cosmic vacuum cleaner, pulling thousands of galaxies toward it. Scientists call it the Great Attractor. So, what is it? A super dense black hole? A cluster of dark matter? Are you ready for the truth? We have no idea. The cruel cosmic joke is that we can't even see it. By pure bad luck, the Great Attractor sits in the zone of avoidance. That's a fancy way of saying it's hiding directly behind the center of our own galaxy. The dust and gas of the Milky Way act like a brick wall, blocking our view. Is it only me who thinks that the universe is deliberately keeping a secret from us? Basically, we're like poor sailors on a ship pulled into a fog by a strange force. We know it's there, we can feel its gravity, but we have no idea what this thing is. If the Great Attractor is too heavy, the next place is too empty, and also a bit extreme. The universe usually looks like a spiderweb. Galaxies are everywhere, clustered together. Even the empty space between them usually has a few modest neighbors. But in 1981, astronomers found a patch of sky in the vicinity of constellation Bootes that was just wrong. Too empty, a perfect sphere of nothingness. And it is huge. 330 million light-years across huge. To give you some context, a space this size should contain at least 2,000 galaxies. Do you know how many we found inside? 60. Not 60,000, just 60. It's one of the emptiest places in the known universe. It is so desolate that if our galaxy were in the center of it, we wouldn't have known other galaxies existed until we invented powerful telescopes in the 1960s. We would have looked up and seen nothing but black ink. Not the best scenario for medieval astronomers. Why does this patch of space exist? Standard physics says matter should be spread out evenly. A hole this precise suggests that something cleared it out. Some theories say it's just random. Others whisper about supervoids merging together. But there's always that one creeping thought. It looks artificial, like someone or something cleared the board with a sponge. Now that we have enough room, let's explore the next structure. It's simply too big to exist. Spoiler, it actually does. There is a rule in astronomy called the cosmological principle. It basically says, don't worry, the universe is uniform. Even if you seriously zoom out, everything will still look the same. There are no giant structures. Calculations say that nothing in the universe should be bigger than 1.2 billion light-years across. This limit isn't just a suggestion, it's more like the bedrock of modern astronomy. If things bigger than that limit exist, it means the universe might be lopsided, and physics doesn't allow it. There hasn't been enough time since the Big Bang for anything larger to form. Well, nobody showed those calculations to the giant arc, which was discovered recently. This is a crescent-shaped chain of galaxies that spans 3.3 billion light-years. That's 3 times the theoretical limit. It's enormous. Finding this thing is like walking into a desert where you were told only sand dunes exist and finding a skyscraper. It shouldn't be there. Its existence implies that our fundamental understanding of how gravity and matter work might be flawed. It's a structure that breaks the rules just by being there. Should we go back even further? Maybe to the very beginning. When we look at the heat left over from the Big Bang, the universe is surprisingly even. It's like a warm blanket with the exact same temperature everywhere, except for one spot. In the southern sky, there's a massive bruise, a region that is significantly colder than everything around it. It's also huge. We're talking about 1 billion light-years wide. The odds of this happening by chance are less than 1%. It's a statistical impossibility. Of course, scientists tried to explain it away. Maybe it's an instrument error. Nope. Multiple satellites confirmed it. Maybe it's a supervoid pulling energy out of light. Maybe. But there is a more radical theory gaining traction, one that sounds like science fiction. Some physicists suggest this cold spot is a collision mark. Imagine that our universe is just one massive bubble floating in a sea of other bubbles. Yes, we're talking about a multiverse. If our bubble bumped into another universe billions of years ago, it might have left a scar. Think of it like soap bubbles in a kitchen sink. When two bubbles touch, they flatten against each other. That flattened wall is exactly what we might be seeing right now. A boundary where our reality literally touched another dimension. If that's true, we aren't looking at a random anomaly. We are looking at the first physical proof that we are not alone in this reality. And finally, the most disturbing mystery of them all. We've already talked about the great attractor pulling on our galaxy, but recently, researchers have noticed something much bigger. They've realized that huge clusters of galaxies, and we're talking about hundreds of millions of light years apart, are all drifting in the same direction. It's like a cosmic river flowing toward a patch of sky between Centaurus and Vela. They call it the dark flow. But according to science, the universe is supposed to be expanding in all directions. There shouldn't be any flow. And even worse, there's nothing in our observable universe massive enough to cause this movement. We checked. The visible universe ends about 46 billion light years away, and there is no object big enough to affect all these galaxies. So, what is pulling us? The only logical conclusion is terrifying. Whatever is dragging these galaxies is located outside our observable universe. It's a structure of unimaginable size, sitting just beyond the edge of the map. We know it's there because we can measure its gravity, but its light will never reach us. It is a monster in the dark, forever out of reach, slowly reeling in parts of our cosmos. These places serve as a humble reminder. We have mapped the continents, but we have barely dipped our toes into the cosmic ocean. The universe is full of ghosts, broken laws of physics, and things that make our galaxy look like a speck of dust. Please remember to keep looking up, even if you don't always understand what you see.
Did you know that the moon is rusting? No, not rustic, rusting. Well, that sounds impossible because rust needs oxygen, and the moon, well, it doesn't have it. Or so we thought. Apparently, Earth is leaking its air, and it's marinating the moon. It might have been like that for billions of years. What does this mean? And why do scientists say it's great news for a future lunar base? Well, let's find out. A few years ago, the Indian Space Research Organization sent a probe called Chandrayaan-1 to orbit the moon. Its mission was to take some nice pictures, but it also was carrying a NASA-built instrument designed to chemically map the surface. The readings came back showing something scientists didn't expect on the moon: hematite. It's an iron oxide, or in plain words, rust. It's the same red, rusty material that eats through your garden fence or a forgotten bicycle chain. Finding rust on Earth is normal because our planet is wet and airy. You need a strict recipe to make it happen. You need iron, you need water, and you need oxygen. The moon already has the first ingredient for rust because its surface is rich in iron from billions of years of asteroid impacts. But the other two ingredients are missing. There is no atmosphere to provide oxygen, and there is no liquid water gathering on the surface. But it goes beyond that. Space actually hates rust. The sun constantly blasts the moon with the solar wind, a stream of fast particles made mostly of hydrogen. Well, these particles tend to strip oxygen away from rocks instead of adding it. All of that makes it obvious why hematite doesn't belong anywhere near our satellite. But these results don't lie. The presence of hematite means that somehow, despite the vacuum and the sun's particle stream, the moon is getting a steady supply of oxygen. It's not coming from deep space or the lunar core. Also, the rust isn't spread evenly. The data showed that the hematite is more concentrated on the side of the moon that faces Earth. The far side is mostly clean. Now, the only oxidizer close enough to do the job is Earth. We learned at school that Earth's atmosphere ends at the Kármán line, about 62 miles up. That's where space officially begins. But that's just the thick part. In reality, Earth is wrapped in a gigantic invisible cloud of hydrogen called the geocorona. It's enormous. It glows in ultraviolet light, and it stretches almost 400,000 miles into space. That's farther than the Moon's orbit. This means that despite being very far away, the Moon is still within the outer edges of Earth's atmosphere. If you were standing on the Moon, looking back at Earth with a telescope that can see ultraviolet hydrogen, Earth wouldn't look like a blue marble. It would look like it's wearing a huge, fuzzy, glowing halo. Now, when we picture Earth and the Moon, we imagine a huge, clean gap between them. Two worlds separated by nothing. But that nothing isn't actually empty. The two are already connected by gravity, tugging on each other nonstop. But there's another kind of connection most people never think about. Earth is surrounded by an invisible force called a magnetic field. It's created deep inside the planet and stretches far out into space. We don't see it, but it's the reason compasses work and the sun doesn't strip our atmosphere away. This magnetic field doesn't just stop at Earth's surface. It doesn't sit there like a perfect bubble either. The solar wind pushes on it non-stop, stretching it out behind Earth into a long magnetic tail that reaches hundreds of thousands of miles into space, like a tail trailing behind a moving comet. That tail is how Earth's oxygen ends up on the Moon. The sun slams into Earth's upper atmosphere, knocking oxygen and nitrogen atoms loose and turning them into charged particles. Normally, they drift off into space, but because they're charged, Earth's magnetic field grabs them and sends them backward, down the magnetic tail. Most of the time, the Moon is off to the side doing its own thing. But once a month, right around the full moon, it slides straight into Earth's magnetic ponytail. Inside that tail, Earth blocks the harsh solar wind and gives the Moon a few days of calm. But it's still moving straight through particles leaking from Earth. Those particles collide with the surface and react with the iron in the soil. Repeat that long enough, and it adds up. Earth loses tiny traces of its air, and the Moon quietly collects them, using its weak gravity like a slow, patient net. It's like driving behind a dirty truck. Dirt flies off of it, but you don't really notice until it starts sticking to your windshield. The same thing happens on the Moon, except, no windshield. We actually have proof of this happening in real time. A Japanese probe called Kaguya was hanging out in lunar orbit, and its sensors spiked when the Moon passed through Earth's magnetic tail. It detected a surge of high-energy oxygen ions. Scientists call it the Earth wind. It acts like the solar wind, except instead of being hot particles from a star, it's made from leftovers of our own atmosphere. And this suddenly makes the Moon part of a much bigger story. Scientists think this kind of atmospheric escape can help explain what happened to planets like Mars. The red planet doesn't have a global magnetic field today, but long ago it probably did. When that shield failed, its atmosphere had a much easier time leaking away. Studying Earth and the Moon is like watching a version of that process on replay, just in slow motion. And it's not unique. Near the edge of the solar system, Pluto's thin atmosphere is slowly being stolen by its moon Charon. Ooh, larceny in space. Pluto's gravity is so weak that its atmosphere stretches far into space. When those gas particles drift close enough, Charon's gravity simply grabs them. No magnetic field needed, just a leaky planet and a nearby moon pulling the material away. Now, when the Apollo astronauts brought lunar soil to Earth, it was already loaded with hydrogen from the solar wind. The sun sprays the lunar surface with hydrogen, and over time, that hydrogen gets baked straight into the dust. That's the H, but you still need the O2 to create water. The regolith may already contain trace amounts of oxygen locked into minerals and dust, not as ice, but as something that can potentially be processed. It would mean that regolith is not just a nuisance that destroys gear and rovers. For a future lunar base, even small amounts matter. Water is heavy. Launching it from Earth is a nightmare. If the moon can supply even part of what astronauts need, it could make a difference. Now, another cool side effect of this discovery is that drilling into the moon could tell us more about Earth's history. You see, our planet is terrible at keeping records. It's like a giant recycling machine. It's always changing. Tectonic plates grind the crust down and melt it into magma. Winds and rains erode rocks. The air that we breathe now is different from the one that was around 2 billion years ago. Now, we can guess what the ancient atmosphere was like, but we don't have a physical sample. The moon is the complete opposite. It's cold and static. When those Earth particles land on the moon, they get buried under dust and stay there. They're trapped in the crystal lattice of the soil. Think of the lunar surface like an ice core in Antarctica. The deeper we dig, the further back in time we go. If we drill a core sample on the moon, we might, theoretically, find layers of oxygen and nitrogen from 2.5 billion years ago. That is right around the Great Oxidation Event, when microbes first started pumping oxygen into our atmosphere. That could tell us something we don't know. It could prove that life started earlier than we thought. It could show us exactly how a dead planet turns into a living one. That's another answer you can give the next time somebody asks why we should go back to the moon. Also define the green cheese. Hey, just Google it. So get this. Earth might be actually located near space highways that could connect us to other worlds. That's because our sun sits right in the center of a giant bubble filled with hot gas, carved out by ancient supernovae. And this bubble likely has tunnels linking us to distant galaxies. So, does it mean it's time to develop space tourism? Well, let's figure it out. Most of us think space is just planets floating around in eternal darkness. But new research hints at the possibility that it might not be really true. It turns out our whole solar system is actually sitting inside a giant bubble of hot, thin gas. And it gets even better. Scientists now think there might even be a weird cosmic tunnel or channel made of this stuff. It supposedly stretches out toward faraway stars. Astronomers spent years mapping the sky, and after they put all the data together, they found something that looks like a long pathway of hot, low-density plasma, which is basically that very thin, superhot gas. And this so-called channel reaches out from around us to distant constellations. Researchers from Germany confirmed this discovery using data from a space telescope called eRosetta. We'll talk about it a tiny bit later. Now, interestingly, scientists discovered that our solar system sits inside something called the local hot bubble a long time ago. This bubble is actually a huge area, about 1,000 light-years wide. It was created when several stars exploded in giant supernovas millions of years ago. Those explosions heated up the gas around them and basically carved out this bubble of hot, low-density space. And their shock waves created weak points in the bubble around us, eventually forming interstellar tunnels. That cosmic event was so huge that the leftover hot plasma is still floating around us today. Now, to understand this bubble better, scientists used eRosetta, which is an X-ray telescope. It scans the sky looking for soft X-ray light. That's a kind of light we can't see with our eyes. It comes from hot gas, old supernova leftovers, and other structures in space. They also compared eRosetta's new information with older data from another X-ray telescope called ROSAT. And finally, putting all this information together, they were able to make a much clearer map of what's around our solar system. Mind you, this wasn't easy. They had to divide the sky into thousands of tiny pieces and carefully measure faint signals coming from warm gas, empty pockets of dust, and other stuff floating in space. But their effort paid off. After sorting through everything, they managed to figure out the faint glow of hot plasma around us. It proved we were not just drifting through empty space. We're inside a giant burned-out bubble created by extinguished stars. But what really surprised scientists was the discovery of some kind of channel. It looked like a long tunnel in space, cutting through the hot gas around us and connecting our part of the galaxy to star systems far away. They also found signs of another channel pointing toward the Canis Major constellation. And those might not be the only ones. The data suggests there could be a whole network of such paths, branching out through space. Each one works like a hidden back road. Scientists used to guess that the space around our solar system might have little pockets or rooms carved out by old exploding stars. We could probably imagine them like caves inside outer space, but no one had the necessary tools to actually prove it. But now, thanks to that new data from the eRosetta telescope, they finally have a clear picture. The telescope showed that the space around us wasn't just empty. It's full of hot, thin gas and strange shapes, including tunnels and bubbles. This proves at least part of what older scientists predicted. We're living inside a giant bubble of hot gas, and that bubble connects to other bubbles through long, low-density channels. The new study also shows that the pressure inside our bubble is lower than scientists expected. This might mean the bubble isn't closed. It could be open in some directions, letting that hot gas flow out into other parts of space. In short, this hot bubble isn't simple at all. Parts of it might be open pathways, and other parts look blocked off. Being inside it is kind of like trying to walk through a forest. Some areas have clear trails, and others are packed with trees. And even though astronomers have mapped big chunks of the bubble and found these strange channels, there's still a lot they don't fully get. Some paths look like they're made of a bunch of connected empty pockets, and others look totally closed. To understand the whole picture, we'll need better tools and more data. Hopefully, with stronger X-ray telescopes, deeper sky scans, and better computer models, we'll finally understand the nature and structure of the bubble we're living in. We might be able to make a kind of map of those hidden channels and learn how they affect things like cosmic rays, dust, and the solar wind around us. Now, speaking of telescopes, we can't help but mention the one that helped us figure out the very existence of the bubble around us. The thing is, scientists have been trying to understand a faint glow of low-energy X-rays that seem to cover the whole sky. For many years, they weren't sure where this glow was coming from. And then, the NASA-supported DXL mission finally helped to solve the mystery. Researchers used old but reliable detectors that first flew on a rocket in the 1970s. With these instruments, they confirmed that most of this X-ray glow came from a huge area of extremely hot gas around us. It was named the local hot bubble. Back in the 1990s, another X-ray mission called ROSAT made pretty good maps of the sky, and it found something surprising. Comets gave off soft X-rays too. Later, scientists realized this happened when the solar wind, fast particles from the sun, collided with neutral atoms. This process, called charge exchange, can happen almost anywhere in space. Because of this, some scientists started to doubt whether the local hot bubble was really the main source of the X-ray glow. So, to test this, DXL launched on December 12, 2012 from New Mexico. The rocket flew high above Earth's atmosphere for about 5 minutes, giving the instruments a clear view of space. The goal was to look at a worst-case situation where lots of charge exchange might occur. Right now, our solar system is moving through a cloud of cold gas in space, known as the local interstellar cloud. That's also nicknamed the local fluff. Cute, right? Neutral hydrogen and helium atoms from this cloud move through our solar system at very high speeds. Hydrogen gets affected easily by different forces, but helium mostly follows the pull of the sun's gravity. Because of this, the helium forms a focusing cone, a region with extra helium that Earth passes through every December. This cone is the perfect place to look for charge exchange, since it holds more neutral atoms than usual. But what happens during charge exchange? The solar wind comes from the sun's corona, the star's superhot outer layer. The particles in the solar wind have lost many of their electrons. When one of these particles hits a neutral atom, it can steal one of the atom's electrons. The stolen electron briefly gives off a soft X-ray. This is how the glow is created. Now, to compare things, the researchers also looked at old ROSAT data from 1990, taken in a direction away from the helium cone, where charge exchange should be weak. By putting everything together, the scientists found that only about 40% of the soft X-rays come from inside our solar system. The rest, the majority, comes from the local hot bubble. This means the huge cloud of hot gas around us really is the main source of the X-ray glow. But let's get back to the discovery of the Space Intergalactic Tunnel. It's a valuable lesson for us that space might look calm and empty when we look up, but that's not true. Space around us actually contains dust, plasma, radiation, magnetic fields, and mysterious tunnels. All of these things mix and swirl together, making space much more complicated than a simple vacuum.
A giant wormhole, or simply said, a connection between regions of space-time, opens up in space near Earth. Our world faces chaos unlike anything before. Satellites incinerated, skies ripped open by radiation storms, entire power grids blacked out. The atmosphere is swelling and scorching, the oceans are boiling, the magnetic shield is shattering. Suddenly, the wormhole destabilizes. Space-time starts to unravel, tearing Earth apart from the inside out. People are seeking shelter, but nothing can save them anymore. Look at this devastation. This isn't just a sci-fi scenario. It's a cosmic apocalypse waiting to happen and rewrite the fate of humanity. The thing is, some black holes might actually be secret space portals. It may sound like something straight out of Stranger Things, but it's not. Scientists have been wondering for years if some black holes could actually be wormholes in disguise, tunnels through space and time. And now, a new study says this might actually be possible, at least in theory. Wormholes are like cosmic shortcuts that let you pop out in a totally different part of the universe. Unfortunately, we've never found one, and the whole concept still lives in the land of what if. Here's the problem. To actually make a wormhole work, you'd need something called negative energy. That's not just rare. It doesn't even exist in the regular universe. Maybe in some weird world of quantum physics, but even there, it's super uncertain. Still, scientists have a wild thought. What if some black holes aren't just giant space vacuums that swallow everything around them, but are really hidden wormholes? The odds of that are tiny, like winning the lottery while getting struck by lightning and discovering extraterrestrials at the same time. But mathematically, it's not impossible. That's where the new study comes in. Researchers looked at a weird type of black hole called a Schwarzschild black hole. These ones don't spin, don't have electric charge, and, very predictably, are totally hypothetical. They're just the math version of a black hole, not something we've seen in space. In any case, the team studied something called quasi-normal modes, which is just a fancy way of saying how space vibrates around a black hole when you mess with it. These vibrations don't go on forever. They fade out like the ringing sound you get when you hit a bell. By analyzing those space-time vibes, scientists tried to figure out if they could tell the difference between a regular black hole and a wormhole pretending to be one. It turns out that it's super hard to tell this difference. But maybe that's the point. Wormholes might be hiding in plain sight, wearing black hole costumes like it's space Halloween. Wormholes could copy a black hole's behavior almost perfectly, at least on paper. The researchers uploaded the whole study to Arxiv, which is where science nerds drop their ideas before they hit the big journals, and it's already been published in Physical Review D, which is a serious physics magazine. The coolest thing, though, is that it isn't a brand new idea. Scientists have been debating this whole black hole or wormhole thing for decades. Back in 2021, some researchers wondered if the giant black holes at the centers of galaxies, called active galactic nuclei, were actually wormhole entrances. And in 2022, a team in Bulgaria said that the light coming from a wormhole could look almost exactly like what comes from a black hole. There's also this sci-fi level theory that some black holes might be paired with opposite twins, called white holes. A white hole basically spits stuff out instead of sucking it in. Together, a black and a white hole could form a wormhole tunnel. But no one's found a white hole either yet, so that idea is still just theory. By the way, in this latest study, the authors have shown that wormholes and black holes not only look similar, but also sound similar, at least in how space-time shakes around them when they get hit with something. So our next move should be fine-tuning our scientific models, especially near the part of the wormhole called the throat. Scientists want to see if wormholes could fake even more black hole-like behavior, but it's tricky. Some of the math gets super hard. In any case, how about finding out more about these mysterious wormholes? You've seen them in every second sci-fi movie, magical space tunnels that let you skip across the universe. Einstein was the first one to have dreamed them up. Wormholes are still 100% hypothetical, and we've never spotted one. But that doesn't stop people from theorizing. Like, what if a wormhole started sucking in matter like a black hole does? If a wormhole started eating stuff like dust, gas, or space debris, it would create a plasma tornado, a literal space firestorm in its throat. And this twisty storm would eventually blast out the other side of the wormhole, firing hot plasma at nearly 125 million miles per hour. That's about 1/5 the speed of light. It would also be insanely hot in there, so hot it could probably trigger nuclear fusion. Of course, all of this is still just theoretical. No one's seen a wormhole do this. No one's seen a wormhole do anything, actually. But the math says it could happen, if we ever find a wormhole. The bright side of it all is that we would probably spot an event with so much drama. Even though wormholes don't have an event horizon, aka the point of no return, like black holes, they still bend light. Normally, you might not be able to see something like that, but this thing is so absurdly bright from the plasma firestorm that you would actually see it glowing in space. Think of it like a black hole, but with a glowing center instead of just darkness, and a jet of flaming plasma shooting out one side like a broken space faucet. Still, don't get your hopes up for spotting one anytime soon. Even if we did find a wormhole, it probably wouldn't last long. It could break apart or transform into a completely different type of space-time before we even realized what we were looking at. Plus, keep in mind that wormholes might look almost exactly like black holes unless you know what kind of light polarization, how light waves line up, to look for. Now let's talk a bit more about black holes themselves. You're likely to know them as insane space beasts that suck up everything nearby, gas, dust, even light. And once something crosses a black hole's event horizon, it's trapped forever. Scientists say that inside, everything gets crushed into a tiny point called a singularity, where the usual rules of physics totally break down. But back in 2010, a physicist named Nikodem Pawlowski had a crazy idea. What if black holes don't have singularities? Instead, what if the center of a black hole is actually a doorway to another universe? Maybe our entire universe was born from matter shooting out of a black hole in some parent universe. Pawlowski's theory uses something called torsion, which is like a weird gravitational twist that stops matter from getting crushed infinitely. Because of torsion, instead of crashing into a singularity, matter inside a black hole can create a tunnel, a so-called Einstein-Rosen bridge, or simply a wormhole, connecting a black hole to a white hole. So, imagine matter falling into a black hole in one universe, then popping out of a white hole in another. Pawlowski thinks this could explain the Big Bang, but as a big bounce, meaning the universe keeps cycling through phases of expansion and contraction, not just one huge explosion. Sadly, if such a tunnel existed, it would be a one-way trip. Nothing would come back through to the original universe. Some scientists are still skeptical because torsion hasn't been proven yet, but other experts think Pawlowski's model is super promising. They even go further and say that our whole universe might be living inside a giant black hole hundreds of billions of light years wide. Now, we just need to figure out how to test this. Future space studies might give us more clues, like checking if our universe is closed, which basically means that it's curved, without an edge, or digging deeper into cosmic background radiation, which is the leftover glow from the Big Bang. Hey, does anyone remember the gold rush? Back in the 19th century, prospectors were flooding California rivers with a pan in hand, chasing wealth. Well, scientists now say it might be time for the moon rush, because apparently precious metals worth over $1 trillion could be hiding underneath the surface of the moon. That's a lot of money. However, can we really reach it? And if so, who does it belong to? If you have ever paid close attention to the pictures of the moon, you probably noticed a lot of holes and craters. Our satellite is like a giant Swiss cheese. It has over 1.3 million craters, if you count those larger than 0.6 miles. But today, we're focusing on about 6,500 really big ones, those over 12 miles wide. Those were not made by little green men or little green moles, but rather by asteroids crashing into the moon since eternity. Scientists compared moon scans to meteorites, and after crunching the numbers, they think there could be a fortune in platinum hiding in those craters. What's exciting is that many of these resources could be just a few feet beneath the surface. The moon doesn't have an atmosphere like Earth, so there's no wind, rain, or earthquakes messing things up. That means those asteroid crashes left their priceless metals pretty much right where they landed, undisturbed in lunar dust for millions of years. With each crater like a giant space bowl catching platinum, iridium, palladium, and other metals. On Earth, we have to drill super deep just to get a tiny bit of these. By the way, did you know that most of the mineable gold on Earth likely came from ancient meteorites? When Earth first formed, almost all the original gold sank into the core. The stuff we can actually dig up today is probably what's left when space rocks slammed into the crust billions of years ago. So maybe you wonder why not reach for the asteroids and mine there? Well, that's because they're out of reach. Yes, in theory, it would be possible to mine from asteroids, but obviously the moon is way closer and easier to get to than any other giant rocks floating in space. We've already walked on it and brought back pieces of it to Earth, so it's fair to say we are familiar with it. This makes mining it a much smarter step than chasing unpredictable asteroids. However, asteroids are next on the list. Also, when it comes to mining the moon, it's not just about the prize. Some of those craters have frozen water. We know that because several missions, like NASA's Lunar Reconnaissance Orbiter and India's Chandrayaan-1, have found frozen water ice in dark craters near the moon's poles. This ice is super valuable because it can be broken down into oxygen and hydrogen. They are the parts needed to make rocket fuel. It could also be purified for astronauts to drink, or even used to help grow plants. Imagine filling up spaceships with fuel right on the moon before flying off to other planets. Not only does that sound pretty cool, but it's also economical and convenient. That would save us a ton of money and effort. And if we're already stopping to refuel, why not stick around and set up shop? It's about building a whole new space base and turning the moon into a launching pad for exploring deeper space. A moon base would let scientists study wild space weather, practice building habitats, and test robots in real lunar dust. I can't be the only one excited for the future where robots stream their live missions from the moon. The skills and knowledge we develop there could be essential for living on Mars or exploring the moons of Jupiter and beyond. This is not as far-fetched as you might believe. Companies like Astroforge and Karman Plus are working on tech to mine asteroids, and maybe the moon someday. NASA's Artemis program is trying hard to set up a sustainable human presence on the moon in the next decade. And Europe's space agency is also eyeing lunar resources. So yeah, the idea of people and robots working together on the moon is probably just a matter of time. Still, it's not as simple as it sounds. there are big questions that humanity faces. Just like with the original gold rush, it's a bit of the Wild West when it comes to rules. The Outer Space Treaty, signed in 1967, says no country can claim the moon as its territory. However, it's pretty vague when it comes to private companies mining resources. So, if you build your rocket and mine some platinum first, is it yours? Well, as for right now, it's a guessing game. Countries are debating and trying to figure it out before the space gold rush turns into a lunar free-for-all battle royale. Then, there's the challenge of protecting the moon's one-of-a-kind environment. Some craters are so quiet that scientists dream of turning them into giant space observatories that study the universe without any radio noise from Earth. Mining nearby could shake things up or kick dust into the air. Lunar soil could damage the sensitive gadgets and ruin the billion-dollar science experiments. That would definitely annoy researchers. Plus, some parts of the moon have been untouched, and mining could wipe out cool spots we haven't even fully explored yet. So basically, we want to make sure we don't turn the moon into a lunar construction site before we've learned all its secrets. That's why some experts suggest setting up protected zones on the moon, like national parks here on Earth, where mining and heavy machines just aren't allowed. That way, we get the benefits of lunar resources but keep the moon's most important areas safe for research and discovery. But here's an even bigger question. How is this thing going to affect us casual Earthlings who can't take a walk up to the moon with our metal detectors and explore? The moon's rare metals aren't just worth a lot. They could actually be super useful for future tech. Platinum group metals, which might be found in lunar soil, are used in things like medical gear, satellites, and even some types of batteries and fuel cells. If the moon really is sitting on $1 trillion treasure, it could boost tech industries and possibly lower costs. There's also helium-3, a rare isotope found on the lunar surface. Scientists think it could someday be used for nuclear fusion, providing a clean, powerful source of energy that doesn't create greenhouse gases or long-term radioactive waste. If fusion becomes possible, even small amounts of helium-3 could power entire cities. One cool perk of using resources from space is that we could cut down on all the digging and pollution here on Earth. That means less damage to our environment and more sustainable ways to keep up with our growing population's needs. On the other hand, all these new opportunities could create new challenges. Of course, there's going to be a cosmic tug-of-war with who gets the goodies. Nobody wants the fear of missing out on a moon rush. Bottom line, lunar mining isn't just a science experiment. It's something that could affect economies, technology, and the environment here on Earth, for better or worse. When I was a kid, hundreds of years ago, we had the moon bases on the covers of our science books. One of the reasons why moon landing projects became so rare is that it just wasn't financially viable. Why should a country spend resources to get to the moon if there's nothing valuable up there? However, now that we think there's something out there, everything could change. That's why I already imagine myself working 9 to 5 on the moon, fixing robots and growing moon plants. But it's time to get back to Earth, so to speak. Nobody's setting up a moon McDonald's or booking lunar Airbnbs just yet. Even the most optimistic experts say we're still decades away from big mining operations or permanent lunar bases. For now, most missions will be robotic, experimental, and with price tags that will make your head hurt. So until we all get our moon mining helmets, it's something to think about while moon gazing. What about that wealth hiding on the bright side of the moon? Thank you for watching. A huge invisible danger zone is hanging above Earth, messing with satellites, zapping electronics, and giving astronauts a headache. Scientists call it the South Atlantic Anomaly, and it's kind of like the Bermuda Triangle of space, because weird stuff happens there and nobody fully understands why. Want to know more about this thing? Well, Earth has a magnetic field that protects us from dangerous radiation from the sun. We'll talk about it later. And over one spot on the planet, right above the South Atlantic Ocean, that shield gets weirdly weak. It stretches over South America and parts of Africa, creating a sort of magnetic soft spot. That weak spot is bad news for anything flying up there. When satellites travel through it, their systems can freak out. Computers freeze, data gets scrambled, and sometimes entire instruments shut down. Basically, the space version of your phone glitching out right when you need it most. Astronauts have to be extra careful in this region too. When the International Space Station passes through the anomaly, radiation levels spike. It's not enough to fry anyone, but it's surely not fun. The equipment can take a serious hit. No one knows exactly what's going on yet, but scientists think the SAA might be a clue that Earth's magnetic field is shifting. If that's true, it could mean big changes for the future, for us all. You see, the South Atlantic anomaly is connected to Earth's molten insides. Deep beneath the surface, the planet's core and mantle are constantly moving, flowing, and clashing. The outer core is a swirling ocean of liquid metal, and the mantle above is hot, solid rock. Under Africa, there's nothing to cool things down. The mantle is hotter than usual, which creates certain instability in the magnetic field above. As for South America, there, the Nazca Plate is dragging rock and debris down toward the core. This cools things off and keeps the field more stable. Such a wild temperature difference seems to be fueling the anomaly. According to some sources, it drives it across the Atlantic. The anomaly is slowly drifting westward. The thing is, Earth's magnetic field protects us from dangerous radiation from space, powerful solar winds, and wild swings in temperature, and keeps our atmosphere in check. But over millions of years, the magnetic poles have flipped. When it happens, north becomes south, south becomes north, and during those flips, the field can weaken. And some scientists thought the South Atlantic anomaly might be a warning sign before a full magnetic reversal. It could mean disaster to humans, but we'll talk about it later. The good news is, these flips take over. On average, Earth flips its magnetic poles about 2 times per million years. That means the next reversal could be hundreds of thousands of years away. Nearly 600 million years ago, our planet's shield almost failed, but at that time, it could have been a good thing. Scientists think this near collapse might have triggered a massive evolutionary boost and helped the first complex life forms to evolve. Back then, during a period called the Ediacaran, the magnetic field weakened drastically and stayed that weak for about 26 million years. With less protection, solar radiation removed lighter gases from the atmosphere, leaving oxygen floating freely in the air and oceans. That oxygen helped the first multicellular oxygen-breathing organisms to see the light of day. Those were strange, squishy creatures that hardly resembled animals today. Some were disc-shaped blobs, fronds, or shapeless fans, stretching over 3 feet long. By the way, one of the earliest known animals, Dickinsonia, was among them. It looks kinda pretty, doesn't it? Now, how do we know all this? Thanks to rocks. They're like time capsules. Tiny crystals inside them preserve the power of the magnetic field from hundreds of thousands of years ago. For example, certain crystals from southern Brazil revealed that 591 million years ago, Earth's magnetic field was 30 times weaker than it is now. And rocks from South Africa dating back 2 billion years showed that the field was at full strength back then. Now, let's explore a bit. Deep beneath our feet, there's Earth's inner core. We're used to thinking about it as a perfect solid ball, but new research suggests it might be changing shape. Over the past 20 years, parts of the inner core may have bulged or dipped by more than 300 feet. That's like a skyscraper popping up or sinking deep underground inside the planet. This core spins independently from the outer liquid core, which creates the magnetic field that shields us from dangerous solar radiation. The magnetosphere is non-negotiable. Without it, Earth would lose its atmosphere over time. Water would vanish, and life as we know it wouldn't survive. It basically keeps the planet alive. Without it, Earth could turn into a barren Mars, which lost its magnetic field billions of years ago, and along with it, almost all its atmosphere. So why is our planet's inner core deforming? It seems to happen where the solid inner core meets the super hot liquid outer core. The molten metal flows around it, and combined with the tug of an uneven gravity field, likely warps its edges. Scientists can't drill down to the core to check this theory. It's 3,200 miles below the surface. But they can track seismic waves from earthquakes as they ripple through Earth. They measure how these shock waves bend, slow down, or speed up, and it can help figure out what the inner core is made of and how it moves. That's probably how they know that the solid inner core is slowly growing, freezing layer by layer of the liquid outer core. But don't worry, it'll take billions of years to fully solidify. By that point, life on Earth would probably already be gone anyway. The sun's gonna swallow our planet long before the inner core stops moving. But let's get back to the topic that, I bet, worries you most. What if Earth's magnetic field just vanished one day? Well, the planet would be hit by a storm of charged particles from the sun. Satellites would start glitching and power grids would go down. We would get zapped with higher levels of UV radiation, the kind that can cause all kinds of serious health issues. In short, it wouldn't be instant doom, but life would get a lot trickier. Luckily, now we know that a magnetic field doesn't just vanish overnight, but ours has been slowly weakening for over a century. So what would life on a planet with a super weak magnetic field look like? You would just have to throw away your compass. It wouldn't point north anymore, just towards the nearest patch of strongest magnetism, wherever that may be. The northern and southern lights would go insane, appearing closer to the equator, all because charged solar particles would be able to get through the atmosphere more easily. Satellites would be under constant attack. Solar particles would fry their electronics, mess with memory, and cause what scientists call single-event upsets. High-frequency radio signals would also get scrambled, thanks to free electrons in the ionosphere. Over time, the solar wind could even start wearing down the ozone layer, leaving us all more exposed to UV radiation. Now, let's decrease the level of drama. A magnetic field isn't the only thing keeping a planet alive. Mars did lose its magnetic shield about 4 billion years ago, and most of its atmosphere got blown away. But Venus has no global magnetic field, but still has a thick atmosphere. If Earth lost its magnetic field completely, we wouldn't instantly vanish, but life would definitely change, and we would have to get used to these drastic changes.
Just when you think space couldn't get any more weirder? Hey, check my grammar. The universe throws a curveball in the form of a giant glowing bubble that's too perfect to be real. Astronomers have spotted something strange drifting through our galaxy. And it's not a rogue planet, which is a space body the size of a planet that doesn't orbit any star. It's not a star itself either. It's not even your average supernova remnant. It's a perfectly round sphere, and scientists are stunned. Astronomers were going through data from a super powerful radio telescope when they spotted something that looked like a perfect round bubble. At first, they thought it was the leftovers from a massive star explosion called a supernova. But the weird part was that the object was too perfect. Normally, such explosions leave behind messy, uneven clouds. And the newly discovered one looked like someone had drawn it with a compass. The scientists named the space bubble teleos, which means perfect in ancient Greek. They've already looked at all the possible explanations, but none of them really make sense yet. This strange space body was discovered thanks to a telescope in Australia called ASCAP. It's been scanning the sky and finding all kinds of weird circular objects. This research was part of a project called the Evolutionary Map of the Universe. Some of the faraway circles, known as ORCs, which is short for odd radio circles, have already puzzled scientists. But this one is different because it's inside our own galaxy. At the same time, even though Teleos is technically closer to us, scientists can't quite figure out how close it is. And that's making it harder to understand where it came from or how it formed. The researchers have taken an even closer look at this strange space bubble and found something super odd. It only gives off a very faint glow and only in radio waves, not in visible light or X-rays. Based on that glow, they figured it's most likely the leftover shell of a massive star explosion called a Type Ia supernova, one of the brightest and most powerful kinds of explosions in the universe. This kind of explosion happens like this. A super-dense dead star called a white dwarf starts stealing material from a nearby star. It keeps sucking in stuff until it just can't handle the weight anymore, then it blows up in a huge burst of energy. Now that part makes sense. But figuring out how far away is this thing? Strangely, it's not so easy. Scientists have run the numbers and ended up with two possible distances for Teleos. Either it's around 7,175 light-years away, or it's much farther, about 25,114 light-years away, give or take. Depending on which distance is right, the size of the bubble could be vastly different. If it's closer, then it's about 46 light-years wide. That would make it a pretty young supernova remnant, maybe less than 1,000 years old. But if it's farther away, then it's a giant 157 light-years across, which could be more than 10,000 years old. So, which one is it? That's where things get tricky. Scientists have models that tell us how these supernova leftovers should behave. And one of the most important things they expect to see is X-rays. But you might remember that Teleos doesn't show any, not a single X-ray in sight. That's the big mystery. How can something that should be glowing with X-rays be totally silent? It just doesn't add up and leaves the scientists very puzzled. Another idea the scientists are considering is that Teleos might not be a regular supernova remnant at all. Instead, it might be the leftovers from a rarer kind of explosion called a Type Lax supernova. And this one? It's extra weird. In a normal Type La supernova, the white dwarf star blows itself to bits. But in a Type Lax supernova, it doesn't get totally destroyed. It kind of survives, turning into a zombie star. Ooh. It's damaged, but it's still around. This would actually explain a lot about how Teleos looks and glows. But in this case, it would have to be much closer to us, only about 3,262 light-years away. That would also make it a lot smaller, about 11 light-years wide. The coolest thing here is that there's actually a star at that distance that could be the zombie star that caused all this. But, and it's a big but, like I have, when scientists use other ways to try and measure how far away Teleos is, none of them agree that it could be this close. So, sadly, this theory hits a bit of a wall. Then there's another strange thing. Teleos' nearly perfect spherical shape. That's not normal. Usually supernova explosions are kind of messy and uneven. The blast might push into clouds of space dust or gas, or parts of the explosion might move faster than others. Eventually, the shell that forms gets all lumpy or starts to break apart. But in this case, the object is almost perfectly round, like a balloon, and that's super rare. The only way something could stay this neat and round is if it exploded in a very empty part of space and expanded smoothly in all directions. That's actually not impossible, just really, really rare. Now, considering its unique, probably unnatural shape, could Teleos be an artificial object? Could it be a Dyson sphere? That's a hypothetical megastructure that could completely surround a star and harvest all of its energy. At first, this idea was supposed to explain how we might detect intelligent extraterrestrial life by spotting the energy they use rather than waiting for them to send us a message. You see, here on Earth, we only receive a tiny bit of the sun's energy. Meanwhile, a whopping 386 billion megawatts are shooting out into space in all directions. Not to waste such a giant amount of energy, a civilization could build a Dyson sphere, or more realistically, a Dyson swarm, loads of solar panels orbiting the star. It would help them capture every bit of that power to run their planet, technology, AI systems, and maybe even space travel across galaxies. To understand just how advanced a Dyson sphere-building species would have to be, scientists use the Kardashev scale. It ranks civilizations by how much energy they can use. Type 1 can use all the energy available on their home planet. Spoiler, we're not even there yet. Type 2 can harness all the energy from their star. That's the Dyson sphere level. Type 3 can use energy from an entire galaxy. Think Dyson spheres around every star and even extracting energy from black holes. Right now, Earth's civilization ranks about type 0.7449, give or take. That means that we haven't even maxed out the energy available to us on Earth, including fossil fuels, renewables, and nuclear power. We're still taking baby steps on this cosmic scale. Anyway, the problem with the theory that our perfectly shaped object could be a Dyson sphere is that this example of super advanced technology would give off heat. In other words, there would be thermal infrared radiation, and the object would be unusually bright in the infrared. This could be a sign that something artificial is absorbing the star's energy and re-emitting it as heat. But the scientists have found no heat signatures or anything like that when observing Teleos. So, do we have the final answer? Not yet. The scientists have looked at all the existing clues, how bright the thing is, how big it looks, and how far it might be. And none of the possibilities are totally perfect. Each idea has a problem, especially the fact that we're not observing any X-rays, which should be there according to the usual rules. They still think that regular type LA supernova idea is the best bet for now, but they're not 100% sure. There's just not enough proof to say for certain. So, the mystery continues. The team says we'll need more powerful and detailed observations to really figure out what happened here. But in any case, if something like Teleos can exist, what else is out there, waiting to challenge everything we know about the universe? So, astronomers have spotted about a dozen mysterious explosions in space, and no one really knows what they are or why they're happening. At the moment, they occur about 200 million light-years away. But what if, one day, they get much closer to our planet? Now, this all started back in 2018. One day, telescopes saw a giant boom far away in space. That explosion was incredibly bright, about 100 times brighter than a normal star explosion, called a supernova. The strange thing was that normal supernovae take weeks or even months to fade away. But that one went from kaboom to poof, gone, in just a few days. It got extremely hot and huge, about the size of our whole solar system, and then vanished like it never happened. Scientists were seriously confused. Now, they named the explosion the Cow, because its official name was too long and not exciting at all. Since then, astronomers have been hunting for more of those oddball explosions. And indeed, they've found a few more and given them weird animal names too. That's how we got the koala in 2018, the camel in 2020, the Tasmanian devil in 2022, and the finch, or the fawn, in 2023. All of those are part of a strange group called LFBOTs. That stands for Luminous Fast Blue Optical Transients. Luminous means they're super bright. Fast because they happen and disappear really quickly. The blue color results from their temperature. They're super hot, like 72,000 degrees Fahrenheit. And optical transients means they show up in visible light and don't stick around for long. Even now, the scientists are still scratching their heads, trying to figure out what's causing these bizarre space flashes. It's like the universe is playing a mysterious game, and no one knows the rules yet. At first, scientists thought those space explosions were failed supernovae. That's when a star tries to explode but instead collapses in on itself, kind of like a balloon popping inward. That collapse can create a black hole in the middle that will eat the star from the inside out. But recently, a new theory has popped up, and it's even cooler and creepier. It has to do with black holes, super squished leftovers from exploded stars. They're so powerful that even light can't escape their clutches if it gets too close. That's why they're totally dark and impossible to see directly. Now, some space scientists think that unknown black holes, not too big and not too small, might be pulling in stars that get too close, which produces those explosions. Such holes are called intermediate mass black holes, and no one has actually seen one of those yet. They're like space's biggest mysteries, and we'll try to solve it in a few minutes. But after that, you need to know that a new left bot has shown up in space. It was spotted by a telescope in Liverpool and is currently called AT 2024 WPP. Yep, scientists still haven't picked an animal name, but they're thinking maybe the wasp. What do you think of this name? Share it in the comments. Anyway, one of the scientists is sure that it's the best one since the cow. The most recent space explosion is super interesting and extremely bright, like me. Maybe the brightest one since this whole left bot thing began in 2018. This new WASP boom also doesn't look like a failed supernova. And still, scientists are checking all the data just to be sure. Now, scientists are pretty sure mid-sized black holes that could cause the explosions must exist somewhere. It's like knowing a secret creature might be hiding in space, but no one has gotten a photo of it yet. Some scientists think that this idea is the most exciting, and that it might even help explain dark matter, one of the biggest mysteries in the entire universe. Well, whatever the truth is, a recent discovery might shed light on the existence of mid-sized black holes. The thing is, when it comes to black holes, space has a few different sizes: small, super huge, and something in the middle. The small ones are called stellar mass black holes. They're around 5 to 50 times heavier than our Sun. The giant ones are called supermassive black holes. Makes sense. They're millions or even billions of times heavier than the Sun. They usually hang out in the middle of galaxies. And then there's the mysterious kind in between, called intermediate mass black holes. Those are like the missing link of black holes. Scientists are pretty sure they should exist, but we barely know anything about them, like where they came from, how they grow, or what they're made of. Good news, that mystery might finally be getting solved. Thanks to several new studies, scientists now have some exciting new clues. Researchers have found waves in space, which are called gravitational waves, that seem to come from black holes smashing into each other. And not just any black holes, but ones that are 100 to 300 times heavier than the Sun, which may mean that they're those mysterious mid-sized black holes. Plus, those are the biggest black hole collisions we've ever recorded on Earth. Now, black holes are like space fossils, super old history clues. And those newly discovered black holes could tell us about the first stars that ever lit up the universe. The problem lies in the fact that our tools on Earth, like LIGO, which stands for Laser Interferometer Gravitational Wave Observatory, only catch a tiny moment of these black holes crashing together, literally just a split second. That makes it tough to figure out where those medium-sized black holes come from. So, scientists have a new plan. One scientific lab is getting ready for a future space mission called LISA, short for Laser Interferometer Space Antenna. It's a cool space project by NASA and the European Space Agency, launching in the late 2030s. LISA will float in space and be able to catch the whole story of black hole crashes, not just the final boom. It will track black holes years before they crash into each other. And, if all goes well, we might finally figure out where these mysterious black holes come from and learn even more about how our universe began. So you might be wondering about how LISA will do it. Remember we talked about ripples dashing through space called gravitational waves? Black holes crashing into each other could send them out. Well, LISA is being built to listen for such waves. It'll float in space and look for all kinds of cosmic shakeups, not just huge ones, but also smaller black holes spinning around giant ones. Now, why do gravitational waves matter? A lot of space stuff is too dark to see with regular telescopes, since no light comes from it at all. But gravitational waves don't care about light. They go through everything, telling us about the secrets hiding in the dark parts of the universe. By studying them, scientists hope to learn about things we've never seen before, like black holes, or what really happened at the very start of the universe, and maybe even things we don't know exist yet. Lisa will help us figure out how the universe began, how it's changing, and what it's made of. Now, getting back to those black hole collisions, finding them isn't easy. But researchers have come up with a smart solution. They're using artificial intelligence to make sure the signals from space aren't messed up by noise from Earth or the machines themselves. This work was part of a project focused on combining AI with space science. Scientists are getting more confident that intermediate mass black holes, the ones in between small and supermassive, are real. And they might be some of the most exciting things we can study using gravitational waves, both from Earth and from space. So the next big step? Looking to the Moon. Future detectors placed on the lunar surface could be even better at catching certain types of space waves, especially ones that Earth-based machines might miss. That would help scientists figure out where those black holes dwell in space. Besides this research, scientists are also planning human exploration of the Moon. They're helping NASA choose the best spots for future missions, focusing on big science goals like solar physics, space weather, and how the universe works. Right now is a super exciting time, not just for studying black holes, but also for connecting space exploration and science. Now imagine something so powerful that it could rip the atoms of your body apart in a fraction of a second. Ow! This something is soundlessly dashing through space, not extinct, not alive, stuck in between. If this terrifying monster were moving towards Earth, we'd be doomed. So, is it? Astronomers have found a fast and powerful space object zooming through our home Milky Way galaxy at over 110,000 miles per hour. That's faster than any rocket we've ever made. This bizarre space object got its name of a zombie star, all because it's the leftover part of a star that passed away a long time ago, but is still moving. This zombie star is a kind of an object called a magnetar, a super small, super heavy ball about the size of a city but heavier than the Sun. That makes it one of the densest objects in space. Only black holes are denser. Hey, let's not forget about me, huh? Magnetars also have an incredibly strong magnetic field. The one our zombie guy has is 100 trillion times stronger than Earth's. That's so strong that if the magnetar came close to Earth, it could wipe out every credit card on the planet just from its magnetism, and we couldn't shop anymore. Plus, if a person got too close to a magnetar, like 600 miles or so, it could pull their very atoms apart, and they couldn't shop anymore. Luckily, this magnetar is very far away and not coming near us. When it was first discovered, it was about 15,000 light-years away from Earth. That's a huge distance, so you don't get to worry about your atoms being disconnected yet. Astronomers first spotted the zombie magnetar in 2008. And since only about 30 magnetars are known in our galaxy, it was a lucky and rare find. Scientists use space telescopes like Hubble and Gaia to watch it over time. That's how they discovered it was moving much faster than they thought. Now, astronomers are trying to figure out how this zombie star got such a big kick. At first, they thought that, like most magnetars, this one was born when a giant star exploded in a supernova and the leftover core became a super-dense neutron star. According to their theory, it could have happened near something called supernova remnant HB9. That would make sense since most magnetars are created this way. But when they tracked its movement, they found that the zombie star was moving too fast and going in the wrong direction to have come from HB9. They traced its path thousands of years into the past and still couldn't find any exploding star or star cluster it could have come from. This means scientists now have one more mystery on their hands. Where did this zombie star come from, and how was it made? One explanation is that it came from a white dwarf, which is the leftover core of a smaller star like our Sun after it runs out of fuel. Now normally, when white dwarfs explode, they're destroyed completely. But in rare situations, instead of blowing apart, a white dwarf might collapse into itself and turn into a neutron star. This neutron star could then become a magnetar. This unusual way of forming a magnetar also gives clues about another mystery: fast radio bursts, or FRBs. These are very quick and powerful flashes of radio energy from deep space. Some FRBs come from galaxies that are so old there shouldn't be any exploding stars left. But if magnetars can be born from collapsing white dwarfs, that might explain how those FRBs are still happening. In any case, learning how magnetars form could help us explain many strange and powerful events we see across the universe. But so far, the investigation is still on, and no answers have been found yet. Zombie stars wandering across the universe isn't the only mystery we haven't solved yet. At one point, you might come across one of them while traveling through the cosmos. It looks like nothing. At a distance of 700 million light-years away from Earth, there's a hole, a blank void that has very few galaxies. This is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there thousands of times over. It's the mysterious Bode's void in the constellation of Bodes. Yeah, makes sense. You see, galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters. But between these clusters and threads, there are huge, empty voids that hardly contain any galaxies. Such voids make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Bode's void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, I wasn't around then, all the matter in the universe was packed together quite tightly. Astronomers even thought it was something like a uniform soup. But soon, random quantum fluctuations started disturbing this matter. Some areas became denser, and their gravitational pull became stronger. They began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. If you visited a star cluster called Palomar 5, you'd forget all about voids and supervoids and even zombie stars. Instead, you'd need to concentrate on surviving, since the region is hiding a swarm of over 100 black holes right in the middle. And those black holes aren't just sitting there, they're at work, shaping the cluster nonstop. Palomar 5 is a group of stars located about 80,000 light-years away from us. Normally, clusters like this are dense and tightly packed, with stars all bunched up together. But Palomar 5 is different. It's spread out and has a huge tail of stars, stretching across 30,000 light-years. This beautiful tail is called a tidal stream. It's like the stars are spilling out of the cluster, creating a long river of light. Tidal streams like this are rare and hard to study. Globular clusters like this one are super old. Some are almost as old as the universe itself. But Palomar 5 also stands out because it's the only cluster we know about that still has a tidal stream attached to it. And the black holes inside the cluster might be to blame. They're pulling on the stars in the cluster, messing with their orbits, and slingshotting them right out of the cluster. Or would that be slingshooting? I don't know. Anyway, these stars are what make up the tidal stream. Over time, more and more stars get flung out. Palomar 5 has way more black holes than expected. About 20% of the cluster's mass is made up of black holes, over 100 of them, each about 20 times the mass of our Sun. Of course, Palomar 5 isn't going to last forever. In about 1 billion years, the cluster will completely fall apart. By then, all the stars will have been gone, leaving behind just the black holes. And these black holes will orbit the Milky Way, like a ghostly remnant of a cluster that used to be there. Even though this cluster is creepy enough, there's something even more eerie you can see in space: thick clouds of gas and dust called nebulae. One of the most unusual ones is probably NGC 2392, located 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago, and became popular because of its unusual appearance. It's basically a disk of material with a ring of comet-shaped objects. The tails of these objects stream away from the star at the center of the nebula. The bizarre orange streaks in the outer part of the cloud stretch light-years away in all directions. The middle resembles a ball of twine, but in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Wow.
This terrifying but very much real image emerged just recently. In it, you can see something that looks like it belongs in a science fiction movie. From far above Earth, aboard the International Space Station, an astronaut captured something astonishing over Louisiana. A gigantic jet blasting upward straight into the sky. It looks as if Earth is sending a signal skyward. Can science explain this eerie phenomenon? Apparently, it can. This energy blast is called a gigantic jet, and it's one of the rarest and most powerful kinds of lightning we know about. Unlike regular lightning, which strikes down toward the ground, gigantic jets shoot up from storm clouds, and they can stretch for more than 50 miles into the sky. Sometimes they even reach the ionosphere, the layer where Earth's atmosphere starts blending into outer space. To give you an idea, space officially starts around 62 miles above sea level, and the ionosphere stretches from about 50 to 400 miles up. Shockingly, scientists have only known about gigantic jets for about 20 years, and we're still figuring out exactly how they work. One theory is that something inside the storm cloud blocks the lightning from escaping downward. So all this pent-up energy looks for another way out and ends up blasting upward into the sky. But honestly, we still don't fully understand why it happens. Gigantic jets are also extremely rare. Scientists think that they happen only around 1,000 times a year on the entire planet. And when they do happen, they carry a lot of energy. We're talking more than 50 times the power of a normal lightning bolt. The strongest gigantic jet ever recorded happened in Oklahoma in May 2018. It was intense, reaching a temperature of 8,000 degrees Fahrenheit and releasing about 60 times more energy than regular lightning. In other words, it was a huge burst of electricity flying straight into the sky. Most of the photos we have of gigantic jets come from satellites or astronauts on the International Space Station. But a few have also been captured from airplanes flying over storms. The latest jaw-dropping image was taken on November 19, 2024, by an astronaut aboard the ISS. At first, the picture wasn't released by NASA or any space agency, but one photographer, known for tracking and photographing rare lightning events, found the photo by accident. He was browsing through a NASA-run website called the Gateway to Astronaut Photography of Earth, which hosts photos taken by astronauts. There, he spotted images showing a giant lightning jet. Eventually, the photos were brought to public attention on February 26, 2025, and they've also been turned into a time-lapse video on YouTube. We still don't know exactly about the exact spot where the jet happened. Thick storm clouds cover the ground in the pictures. But based on where the ISS was flying at the time, the jet probably happened just off the coast of New Orleans. Speaking of other images of the gigantic jets, a photographer living in Puerto Rico was taking pictures of a storm moving through the area. That same storm would later grow into Hurricane Franklin. While watching the skies, he saw something truly amazing. Several massive lightning bolts shooting straight up out of the storm clouds, stopping just below the edge of space. No wonder. According to a 2022 study, gigantic jets happen most often in tropical areas, and they're more likely during fast-growing storms, like Hurricane Franklin. Gigantic jets often end with thin, red, branch-like lightning tendrils. These faint red flashes are very similar to another rare type of lightning called sprites. Those sometimes look like giant glowing jellyfish in the sky. In 2023, an astronomer named Stanislav Kaniansky in Slovakia captured one of the clearest images of a sprite ever. It happened during a thunderstorm over Central Europe on August 14th, and he spotted it near his home. In the photo, you can see a huge glowing red structure with zigzag patterns stretching over 31 miles across the sky. But like all sprites, it only lasted a fraction of a second before fading away. Sprites happen when lightning sends electrical energy upward into the upper part of Earth's atmosphere, instead of just downward like regular lightning. This energy creates glowing strands of plasma, which is basically electrified gas, way up in the ionosphere. Since sprites are so fast and often hidden by thick clouds, they're very hard to photograph. But Kanyansky got lucky. The thunderstorm was about 200 miles away from him, so he had a clear view just above the tops of the storm clouds. That perfect angle helped him capture this stunning phenomenon. There are many different kinds of lightning, and some of them are not only rare but also super dangerous. Let's take ball lightning, for example. It's exactly what it sounds like, a glowing, floating ball of light that appears during thunderstorms. It's also one of the weirdest and most mysterious forms of lightning. People have seen these strange light balls, usually about the size of a grapefruit, slowly spinning or hovering just above the ground. Some even say they've seen them float through closed windows or suddenly appear indoors, then vanish after about 10 seconds. For hundreds of years, no one really knew what caused ball lightning. Scientists had no explanation, and most sightings were based on eyewitness stories. Then, in 2012, someone finally managed to capture ball lightning on camera. Since then, different ideas have come up to explain what ball lightning really is. One of the newest theories suggests that the ball is actually a tight bubble of super compressed air. This compressed air bends and spins white light in all directions, making it look like a glowing ball rolling around in the sky. And according to the researchers, ball lightning can be almost 1 billion times more intense than regular lightning that moves in a straight line. Then there are elves. They look a lot like sprites, but instead of looking like jellyfish or dancing shapes, elves appear as huge glowing rings or halos in the sky. And they're massive. An elf can spread out to be up to 185 miles wide. You can even spot them from space or through thin clouds during the day. Dark lightning is probably one of the strangest types of lightning, and most people don't even know it exists. Unlike regular lightning, it doesn't produce a bright flash. Instead, it gives off intense bursts of radiation, especially gamma rays, the most energetic form of light found in nature. Dark lightning happens when high-speed electrons slam into air molecules inside a storm cloud. This creates a burst of gamma rays. They're so strong that they can mess with satellites hundreds of miles away in space. In rare cases, when a plane flies through a thunderstorm, these flashes can hit the aircraft. Some passengers could get a quick dose of radiation, about the same as a full-body CT scan. But worry not. Scientists say these occasions are extremely rare and not a reason to be afraid of flying. And finally, there's positive lightning. You see, lightning is still kind of a mystery, even for scientists. But here's the basic idea. Inside a storm cloud, tiny pieces of ice bump into each other and build up electric charges. Some become positive, others negative. Most of the lightning we see comes from the bottom of the cloud, where there are lots of negative charges. These reach down and zap the ground. But sometimes, lightning comes from the top of the cloud, where positive charges hang out. That's called positive lightning, and it only makes up about 5 to 10% of lightning strikes. Most of the time, those positive charges just zap other parts of the cloud. But sometimes, they shoot all the way down to the ground. That's why positive lightning can strike even when the sky looks clear, because it comes from way up high in the cloud, sometimes miles away from the storm itself. The scariest part is that regular lightning can reach about 300 million volts, while the charge of positive lightning can be up to 1 billion volts. That means positive lightning is much stronger and more dangerous. In 2023, an ex-NASA engineer claimed he built a machine that can lift itself against gravity without using any fuel. No rockets, no fire, no exhaust, just electricity. If true, it would break the most sacred laws in physics and rewrite everything we know about space travel. So, is this just another hoax or a door to the future? The engineer's name is Charles Bueller. He used to work for NASA, making sure rockets don't blow up randomly. He was a part of the Space Shuttle, Hubble, ISS, and other huge projects. Now, Bueller and his team work at a private company called Exodus Propulsion Technologies, trying to build a long-term dream of space engineers, a spacecraft that doesn't need fuel. It's the kind of thing that would instantly change everything about space travel. Just think of the future where you could go to the moon, Mars, or wherever you'd like without spending tons of resources. And he claims that he and his team have finally cracked the code. That they've built a machine that can lift itself in the air without any propellant. You got it right. The team claims to have violated Newton's third law, the basic rule of our world that every action needs an equal and opposite reaction. For example, in rockets, you throw fuel out the back, that's action. Being pushed by it, the rocket goes forward. That's the reaction. A magical device like that would also violate the conservation of momentum. When you push on something, you gain momentum, but something else has to gain equal momentum in the opposite direction to balance the books. But this device would change the total momentum of the system out of nowhere. If you're getting motion without pushing against anything, how in the world did you do that? It's like a balloon that can somehow move forward without blowing out any air. If the machine actually works, there must be some new, unknown force of nature that we've somehow missed in hundreds of years of physics. Bueller himself called it the new force. Let's try to figure it out. To create this magical device, they used electrostatics. Their test device was little, a 30-gram object about the size of a card deck, and it managed to create thrust or push using electric fields, a kind of invisible force made by electric charges. The new force starts working when two things happen in the system. The first one is electric imbalance. There's some electric pressure happening across parts of the device, kind of like air pressure. If it's not spread out evenly across it, for example, one side has more electric push than the other, that's the first ingredient. And that happens when the electric field, the invisible force that electric charges create, is set up just right. It has to spread out in a certain way. Not in straight lines, but uneven and fanning out, like sun rays or the spokes of a wheel. And boom, when it happens, the device pushes on itself and makes the whole object move. At first, the mysterious new force was tiny, barely noticeable, little to no thrust and noise. But with each upgrade, things started to shift. And in 2023, they finally measured enough thrust to overcome Earth's gravity. The weirdest part is that, according to Bueller, in some cases, the thrust keeps going even when the power is off, as long as there's still charge left in the materials. That's weird. That's really weird. That hints at something totally new in physics, something deeper than we currently understand. So now, any honest scientist starts sweating, because that sounds bananas, and frankly, it might be. Bueller admits this is still early work. The team published their discovery and got a patent. By the way, the company includes people who've worked at NASA, Blue Origin, and the US Air Force. They've been tinkering with this stuff for decades. Charles presented his findings at APEC, a conference for people who are passionate about alternative propulsion and crazy stuff like warp drives, anti-gravity, and ways to make Star Trek real. Now, they're actively working on that project. Of course, this stuff got very controversial, and lots of scientists are skeptical. There might be a mistake no one has caught yet, so they want to test the machine in space. If it works out there too, it could change space travel forever. It might be real, because it's not the first time we've discovered something like this. Recently, a startup called Evo Limited claimed that they'd built a quantum drive, another propulsion device that apparently didn't need fuel. They said they're tapping into a weird controversial theory of physics called quantized inertia. It was cooked up by a British physicist named Mike McCulloch. He basically said that inertia, the thing that makes objects resist acceleration, isn't a basic rule of nature, but an effect caused by some weird quantum radiation at the edge of the observable universe. In simple words, if Qi is right, then under the right conditions, you might be able to generate thrust without throwing anything backward. You don't need fuel, just electricity and a clever enough setup. Many scientists don't buy into it, but who knows? Maybe that's why these new inventions could actually work. Anyway, initially, the IVO company was founded by a small team of tech guys who wanted to find wireless power. Their first big idea was called CBAT, capacitive-based aerial transmission. Basically, a fancy way to wirelessly send electricity through the air. But somewhere along the way, they pivoted. They started wondering, if we can move electricity through the air like this, can we move objects too? Can we rethink inertia itself? So, in 2021, they began working on a propulsion device based on this quantized inertia theory. They built the quantum drive around this idea. It was a self-contained electric system. No fuel tanks, no combustion, just a plug-and-play box that makes spacecraft move. They said it's light, stackable, and can be bolted onto a satellite like a toaster. And it weighs just a few hundred grams, way lighter than traditional thrusters. In 2023, they tested it, not in someone's garage, but in a legit vacuum chamber, simulating space conditions. The team said they ruled out every known force that might explain the results, and that it did generate thrust, not a lot, but consistent and measurable. Then came the big moment. IVO and a partner company, Rogue Space Systems, launched the quantum drive into space, and now they're waiting for the results of the tests. A lot of physicists think it's all nonsense. Some of them notice that this stuff is impossible because they'd be perpetual motion machines. Basically, if a device like this actually worked, you could use it to make infinite energy, which violates the first law of thermodynamics. But IVO says they're not doing that. They say Qi works within our normal Newton's laws, just a bit differently. Anyway, all this stuff needs double-checking. Skepticism is so right because a lot of people get some unpleasant flashbacks. In 2001, a British engineer named Roger Scheuer introduced the M drive. It was this weird cone-shaped device that supposedly created thrust without pushing anything out the back. People were super excited. NASA even tested it with their EagleWorks team, and in 2016, they said they've detected tiny amounts of thrust from the M drive. The media absolutely blew up. People and scientists were hyped up, but later, bigger studies, including one from a German university that really went deep, found the sad result. It was just an experimental error. By 2021, the verdict was in. The M drive didn't work. It was all experimental noise, misunderstood data. Another dream went down the drain. Many propellantless designs have crashed into one huge, stubborn wall, the laws of physics. So it's too early to say that these startups just change the world forever, but if it turns out to be real, it's not just a new engine, it's a new era.
Now, you've seen those breathtaking images from NASA. Stars born in clouds of gas, tangled galaxies, colors that look fantastic and vivid. And then someone suddenly says that this isn't real, that NASA edits all these pictures. Well, guess what? They're right. NASA does edit their photos, every single one. The catch is that it's not to deceive us, but rather to reveal what we could never see on our own. You see, color is a weird thing. It's just waves of light and energy flying through space. When these waves hit some object, a banana, a chair, or even a dust particle, the objects absorb some of the waves, eating a part of the spectrum. But some of it bounces back into our eyes. That bounced light is what we perceive as the object's color. There's an entire spectrum of these waves, from short ones to long ones. As they get longer, they move to the red spectrum and turn into infrared, microwaves, and radio waves. As they get shorter, they move closer to blue and violet, turning into ultraviolet, X-rays and gamma rays. Now, right in the middle of that spectrum is a tiny band we call visible light, which is the only part our eyes can see. That's the rainbow we all know and love, and it's an exceedingly small part. So, you might say we barely see the world at all. When light bounces off something and gets into our eyes, our color-detecting cells, called cones, send them to our brain. So when we say, banana is yellow, it means banana ate red, green, and blue waves and reflected yellow waves into our eyes. So the question is space actually that pretty and colorful, or is it all fake? Well, yes and no. Stars emit light, and it travels through space like an unstoppable train. It's flying there, chilling, until it hits something – dust particles, a planet, spaceship, or an astronaut. Every time light hits something, some of it gets absorbed, some of it reflects and continues to travel. So we get less and less light every time it hits something. And when you enter a nebula, which is basically tons of dust particles around a gas cloud, light quickly starts to scatter and disappear. Nebulae, which is the plural of nebula, also grow naturally from ionized gases like hydrogen, oxygen, sulfur, radiating light in specific spectral lines. But it's super faint as well. Remember, our eyes see things only when light bounces off those things in our eyes. On top of that, the color-detecting cones in our eyes aren't so great, in that they need lots of light to activate. We can't see faint stuff. Unless there's something emitting light right there nearby, we wouldn't see anything. In other words, for us, the entire space would be like a room with lights turned off. The potentially beautiful nebulas and planets are there, but if you don't have a lamp nearby, you can't see them in all their glory. When there's lots of light around, rods take over, another type of cell that's great for motion and dark vision, but terrible for color. So in deep space, all we'd see are dim whites and grays. Now, if you were flying around on a spaceship, the stars would look sharp, white, and non-twinkling. You'd be able to see some reddish or bluish tints to the brighter ones, like Betelgeuse or Rigel. But a lot of things would be dim gray smudges at best. The Milky Way might appear as a cloudy band, not rainbowy like in astrophotography. Nebulae would look like faint fuzzy clouds with no color, unless it's something that glows very brightly, like the Orion Nebula. In our solar system, astronauts can see stuff thanks to the sun or when they're near illuminated planets or spacecraft. Planets like Jupiter and Mars retain some color for our eyes. Meanwhile, on Earth, the sky would look black during the day if we had no atmosphere. The sun would be a bright disk in a void as seen from the moon. If only we had super-sensitive cone cells that could detect light better than we do and see even faint things. Oh wait, we actually do have technology for that. Long-exposure cameras and telescopes. Now, telescopes are great for that. They often use long exposures to gather light over minutes or entire hours. That lets them capture photons we'd never collect with our eyes. When telescopes like Hubble or the James Webb take photos, they're not snapping pretty pics like those on Instagram. They're collecting all this raw, invisible data, numbers and faint light that's both within and beyond human vision. The James Webb Space Telescope doesn't even see visible light. It's built to detect infrared or heat. Telescopes like that work like time machines. They show not only distant galaxies, but also what those galaxies looked like billions of years ago. We see stars that have long since gone out, and galaxies that may have already disappeared. All because the James Webb can pierce through gas and dust and see galaxies so old that their light has been stretched into infrared wavelengths as the universe expands. In other words, this telescope isn't made to let us take aesthetic photos. Its main goal is to study the history of the universe. Now, at first, this stuff looks like grayscale or even black images. When the James Webb sends data back, it looks empty. But during post-processing, astronomers map wavelengths they received to visible colors. Every color in those pictures is chosen for a reason. It highlights specific wavelengths, gases, or temperatures. In any case, it shows what would otherwise be completely hidden from our eyes. Sometimes they show only stuff a human eye can see. Sometimes they shift colors or add something to show elements or intensities. For example, let's say you're studying a supernova, a star blowing itself to pieces. You need to see its debris clearly to understand what's going on. That means you'd play with the contrast, or adjust color balance to reveal specific gases and find pale objects near bright ones. Want to check out a weird rock on Mars? You zoom in, adjust the lighting, boost the shadows. Photographers do this every day. So scientists do it too, because clarity means understanding. Even old photos from the Apollo missions have been touched up in modern times. It's like restoring an old film so it looks crystal clear instead of foggy. Without this editing, the most incredible discoveries of the past 2 years, those first galaxies, those newborn stars inside cosmic clouds, would just look static. Is it possible to accidentally misinterpret the color? Of course! For example, images we get of Mars are mostly red, but when we land on a planet, it's more colorful. Most of it is gold, yellowish, tan, or brown. The reason Mars looks reddish is due to rusting iron in the rocks, Martian soil, and dust. It all depends on the lighting, atmospheric dust, and image processing methods. But the fantastic colors themselves are not made up. Galaxies contain billions of stars, gas, and dust, giving off incredibly rich color ranges. NASA's photos are basically translations. Now here's an interesting take. Could we use goggles with night vision or some technology that makes our eyes notice light better, like working with Hubble or the James Webb? Man, the sky would be insane. You'd never be able to sleep again. These magical astronomy glasses should greatly amplify faint light, enhancing and translating colors. Unfortunately, today's night vision tech won't cut it. Night vision goggles work by amplifying visible and near-infrared light, but they display everything in green monochrome, not true color. Meanwhile, infrared goggles detect heat, not color. We need some goggles that raise photon sensitivities by 10,000 or so. If only we were lucky enough, like some animals. For example, snakes can see infrared, bees see ultraviolet light, and birds see more colors than we do. And we can't even imagine how they perceive the world. So yeah, NASA edits their photos, because raw space isn't built for our eyes. It's dark, cold, distant, and silent. But with a little translation, some math, some color grading, some visual storytelling, we can see the invisible. We can study the past and inspire more people to study space in the future. You know, oceans cover around 70% of Earth's surface, and we have only explored 5 to 20% of them. And now, astronomers have found more water, a huge stash floating out there in space by a quasar that's more than 12 billion light-years away. And we aren't talking about just a little puddle. It's a mind-blowing amount of water, about 140 trillion times more than all the water in Earth's oceans combined. It's hanging around a supermassive black hole that's a staggering 20 billion times bigger than our Sun. This black hole is surrounded by a super bright quasar. It gives off as much energy as you get if you gathered 1,000 trillion suns. I can't count that high. Oh, by the way, since light takes time to reach us, we're seeing this quasar as it was when the universe was still very young. Astronomers are sure that the newly discovered water reservoir is the farthest and biggest we have ever found in space. Mark Bradford from NASA's Jet Propulsion Laboratory explains that the environment of this quasar is so unique that it's capable of creating an incredible amount of water. Bradford's team, along with another group of astronomers, has been studying the quasar and the supermassive black hole at its center for quite some time. They've noticed that as the black hole pulls in surrounding matter, it heats up the nearby gas and dust. This process has created a region packed with molecules that have never been observed at such a great distance before. Now, quasars were first spotted around 50 years ago, when telescopes picked up super bright objects way out in space. They're not regular stars. They shine from the centers of distant galaxies and are so powerful they outshine all the stars in their galaxy combined. At the heart of every quasar is a gigantic black hole, which is millions or even billions of times heavier than the Sun. When gas and dust swirl toward the black hole, they heat up and release an insane amount of energy. It makes quasars some of the brightest and most powerful things we've ever seen in space. Looking at quasars is like looking back in time. The light we see from them today has been traveling for billions of years. It gives scientists a peek at what the universe looked like way back in the past. Quasars can help us understand how galaxies formed, how matter spread out, and how the first cosmic structures came together. Some quasars shoot out massive jets of superfast particles. Stretching across space, they can sometimes change entire regions of the universe. But let's get back to that space water, or rather water vapor. When astronomers discovered it, it was floating around the quasar, spread across a huge area hundreds of light years wide. For comparison, just 1 light year is about 6 trillion miles. Even though the gas there is incredibly thin, unlike what we're used to on Earth, it's much warmer and denser than the gas found in most other galaxies, including our own Milky Way. The temperature of this gas is around -63 degrees Fahrenheit, and it's about 300 trillion times less dense than Earth's atmosphere. It does sound extreme, even in space terms, it's unusual. Now, water vapor isn't just another molecule. The very fact that it exists near the quasar hints that the area is regularly blasted with radiation. That's what keeps the gas warmer than usual. To add to the mystery, astronomers also found carbon monoxide and other molecules. In other words, there's plenty of raw material floating around. In the future, this gas could help the supermassive black hole grow even bigger, up to 6 times its current size. But that's just one of many potential scenarios. Some of the gas might get pulled into the black hole, some could form new stars, and some might even get flung out into space. Now, finding water vapor in such a distant quasar means that the basic building blocks of the universe have been around for billions of years. Water is crucial for life as we know it, so its presence so long ago hints that the ingredients for life existed much earlier than we might have thought. But water isn't just important for life. It also plays a key role in how stars and galaxies form. When giant clouds of gas cool down, water helps them collapse, making it easier for new stars to be born. But how did researchers even spot this massive cloud of water? In 2008, Bradford's team started looking for water in space with the help of a special instrument called Z-spec. It was attached to a 33-foot telescope in Hawaii. To double-check their findings, they used another powerful tool, CARMA. That's a group of radio dishes in the mountains of Southern California. At the same time, a different team was searching for water using a telescope in the French Alps. In 2010, the second team found a small hint of water in the distant quasar. It was just one teeny-tiny signal. After that, Bradford's group detected more signals. It was all the proof we needed to conclude that an enormous amount of water was actually out there. Now, our floating cloud of water vapor isn't the only place where we've found water beyond Earth. Scientists have recently made a huge discovery. It turns out there are massive reserves of liquid water hidden deep underground on Mars. So, in theory, future astronauts could use this water to support missions or even make Mars a long-term home. But of course, there's a catch. This water isn't sitting in nice, accessible lakes or oceans. It's buried so deep inside Mars that we have no way of reaching it with current technology. Scientists have figured this out by analyzing seismic data from the Mars InSight lander. It picked up some strange seismic activity, and the best way to explain it is by these hidden water reservoirs. Mars still does have some water today, mostly as ice on or just beneath the surface. But that's nothing compared to the massive amounts of water the planet had billions of years ago. The big mystery is, where did all that water go? Scientists think it could have either escaped into space or moved into the planet's interior, where it might now be trapped as liquid reservoirs or ice deposits. The problem? We have no way of measuring how much water Mars lost. So for now, that question remains unanswered. Earth's moon has water too, but not in the way you might think. Instead of lakes or rivers, the Moon's water is mostly frozen ice, spread out unevenly across the surface. The cold, shadowed poles are especially full of it, since they never get sunlight. A lot of this ice is also mixed in with lunar soil and buried deep underground, making it super tricky to get to. Then there's Enceladus, one of Saturn's moons. It's tiny, just 314 miles across. It's small enough to fit inside Arizona. I think we should try that. Anyway, when NASA's Cassini space probe arrived at Saturn, scientists expected Enceladus to be a barren, frozen world. But instead, they saw huge plumes of icy particles and water vapor erupting from geysers near the South Pole. That meant there had to be a massive ocean hiding beneath its icy shell, sandwiched between the Moon's rocky core and the frozen surface. The fact that this ocean is active and constantly sending material into space makes Enceladus a top candidate for future exploration. We also have Europa, one of Jupiter's moons, and one of the most promising places to search for alien life. Europa has a gigantic saltwater ocean that could be 40 to 100 miles deep. This means it might hold more water than all of Earth's oceans combined. But there's a big obstacle. This ocean is hidden under a thick ice shell, which scientists think is 10 to 20 miles deep. Europa's ocean stays liquid because of tidal forces from Jupiter's gravity. The planet's massive pull stretches and squeezes the Moon, creating friction, which heats up the interior, stopping the ocean from freezing solid. And the most exciting part is that scientists think water plumes might be erupting from cracks in Europa's ice, shooting ocean water into space. Now, if that's true, we could potentially sample the ocean without having to drill through miles of ice. But there are still a lot of unknowns. How big are Europa's water reservoirs? How quickly do they refreeze? And how does the intense temperature and pressure affect the ice? Scientists are eager to figure this out because Europa's ocean is one of the best bets we have for finding extraterrestrial microbes somewhere in our solar system.